Welcome to another coding session. Today I want to look at modules and imports. So currently all the Plum code is in a single file. And that works for now, it works as long as you work on the compiler. But if you want to build some bigger projects in Plum, that's not really viable. And believe me, I've tried. Like my previous compiler Martinez is written in a single file, just one giant 5,000 line file. But for some applications, having a big file kind of introduces unnecessary complexity, or like accidental stuff you have to think about, like in which order do I write my code. For a compiler, that's quite straightforward. It follows a straightforward compiler pipeline. But for the standard library or for some helper packages that are independent of each other but serve some major goal, there is no inherent ordering between these. And having modules that live side by side on the file system is kind of a better fit for that, I think. Right. So what ways are there to support multiple files? I guess the most obvious one is the C way, which is to just include stuff. And yeah, you can just literally include other files and they get copy pasted in here. That is crazy because now you have to make sure that types don't have the same names, that you don't define functions that others have already defined, stuff like that. Yeah, that is horrible. I want my files to be some sort of module or namespace. Basically, each file should have, you can create some helper function in there, and that should be guaranteed not to break any other code outside of that module, outside of that file. So we must prevent name collisions across files and, control which definitions, which names go into the outer scope. I want some control over which names leak, which are imported, but also from the file itself, like which functions are just helper functions here, which cannot be used from outside. And the way I want to do that is similar to Rust, I think. Like among the languages, I know that's the closest one. Let me maybe open a new. Hang on, I can just do that in here. Yeah. Here's a Rust file, and in a Rust project, you usually have some sort of source folder, and yeah, let's say you have some files in here. Then there is one, let's call this test file main, maybe. You can kind of declare, hey, by the way, there's a module named foo, and then you can use foo bar. So this would import some function bar or variable bar or something that is defined within the foo module, this foo file. And yeah, Rust kind of does that in a hierarchical way. So foo itself is just a single file. Here you can have a function bar, I don't know. But you can also, later on, if this file gets pretty big, you can split that up into multiple files as well, without needing to to adjust these imports. Because you can just create a folder called foo, and within that folder, a mod.rs file. And let's say this is some helper module. And in here you have this helper module, and you can use that. And this automatically refers to this folder. So modules are either just files, or they are folders, and then the mod.rs file is kind of the main file within that folder. Plus, I think there's a way to explicitly define modules in your code. Like I think you can just do this kind of thing. Like, rather than this up here, you can define, foo is a module with a function. Which makes sense. If you have, as soon as you have modules, you don't ever want to force people to create folders, to create some, desired module structure. It should also be possible to do that in the same file. Right. And then once you have modules and being able to import stuff from modules, the next question is, how do you control what can be imported? And I think you have to write pub in here to mark this as public, so this can be imported from outside the module. Otherwise, this won't work. Yeah, I'm actually not sure if you have some inner module like this. I think by default that is not public. You have to make that public, kind of like this. So in here, this, really this would just I think this can only be used by foo, something like this. I'm not entirely sure about that. But anyways, I want something similar for plum. And it is tempting to immediately go to, let's have multiple files and imports and stuff like that. But for the beginning, I just want to support modules like this. Just have some sort of module keyword or something. And then, within that, you can easily play around with trying out visibility stuff, trying out how to import things. And once that works, we can then go on to multiple files and kind of map that into modules. All right. So this main file, this test file is already pretty big. So I think let's create some sort of standard lib core plum thingy. And yeah, there was extra stuff in here, like the main function and some random types. But I want to have a small test file to play around with this. And yeah, this was just for illustration purposes. I'm gonna remove that later on. Okay, so in this test file, I just want the bare minimum to play around with modules. So a main function that always returns 0, sure. And I think you should be able to define a module like this, maybe. Using two spaces as a notation. And this compute something, and that's an int, returns an int, always returns something. Yeah, and I think in here, so later on this could just be a file. I think you shouldn't have to, declare modules in, or should you declare modules in the file? No, I think you should just create other files, and those immediately become, modules that you can access without having to do this kind of declaration thing here. Oh, okay. So what I want to work is I want some sort of import system. In Rust, it's called use, or use something. I think import is actually the way you usually talk about that and you think about that. So I think I'm going to go with import. Import foo, maybe. Yeah. Um, In Candy, a previous language, we had some nice syntax for that. We had kind of this to import, like, hang on. This would just import some package called foo from somewhere, like a global package kind of thing. This would import a relative module that lives somewhere next to this module. So this would actually import a submodule. You could, for example, put this into this file, import .helper, because within this foo module, and this mod.rs basically belongs to this foo thingy. Within that, there's a helper module, and that's a submodule. So you could do import .helper to import that. To import siblings, you could do import .foo, and then for each layer, you just add one dot. I think that's, like, at the time I found that really elegant, because you get this, in Linux, POSIX, Unix, I don't know, in, this branch of even in Windows, in most operating systems, you can use dot to refer to the current directory, I think, and dot to refer to the parent directory. So it seemed kind of natural to be able to define a module that is within the current directory like this, and import a module that is within the parent directory, so it's a sibling of ours with this. And yeah, sure, why not generalize that to an arbitrary amount of dots? And that brings me to the second point, that you shouldn't be able to, unlike file paths, you shouldn't just be able to import some internal module. If I'm in main, I shouldn't be able to import foo helper. But instead, I should be able to import foo, and then foo might export helper again. But that's the decision of foo. That's the decision of foo. You cannot just access internal modules that have that accessing has to go through the main module file. Right. So yeah, kind of you can't do that. Like in file paths, you sometimes have to be able to do this kind of thing. In modules, you never have to, because you can just put all the parent navigations at the beginning of that, and then only have one single keyword that defines which module you want. And if you want to access internal modules of that, then you would kind of use postfix stuff and define, I don't know, functions, yeah, kind of like this, probably. So this could maybe work. I'm not entirely sure about this, but I should maybe note there are some other cool approaches to modules as well. For example, Zig. Now let me pull up a browser. In Zig, there's a function at import, which works at compile time while the program is being compiled, and that just returns a normal struct. So if you define, if you have some file and you import, I don't know, foo.zig, then this actually causes the compiler to then parse that foo file and put all the public type and function definitions into a struct. So you get some sort of struct with a member compute that is a function, and so on. Yeah, and this is pretty elegant. Just having these compile time known structs that you pass around. And it is, like, because all of that happens at compile time, it is just as efficient as having a normal module system. Is just one less concept that has to be in the programming language. Because you don't need modules as a separate concept, you just use structs for them. And you can also like create these kind of modules at compile time using other code, because you just create structs at the end of the day. Yeah, that is really elegant. I'm afraid this won't work for Plum though, because we have like a big part of Plum is that it has overloading, and you can define multiple functions with the same name. Is not this purely value-based approach that Zig has, where everything is just a touchable value. Like this, if here you say compute A, this compute function, there may exist multiple functions in the scope with that name, which means that compute cannot be kind of resolved or kind of be looked at in isolation. It only makes sense because it's being called. This is kind of a unit of, you have to look at this together to figure out which compute functions meant. You cannot look at all identifiers in isolation. Yeah, it makes some things really elegant, but it means that we need some sort of separate concept for modules, or like bags of things that may have the same name. Yeah, I don't know. Okay, so you should be able to declare modules like this, and you should be able to import stuff from modules. Right. What else is there? I think this is a completely new, this is not an expression, it's a declaration. In Zig, everything's an expression. This right here, you can write this inside your function. You can write, I don't know, at import standard dot format dot parse int of something, because this is just a struct. In Rust, that doesn't work. You can't just use something and then immediately, that's not an expression. That's not something you can use in normal code. I'm not sure what I want to do. Probably the Rust way of having imports as a separate statement, like kind of thing that just puts names into scope. And yeah. Another aspect of this is, how do you mark things as public? In Zig, there's a pub identifier. In Rust as well. In C, there is no concept of visibility. Well, you define things in your header files instead of your C implementation files. But there is not really a built-in concept of visibility. In Candy, we opted to do something like this to mark something as pub, but this is like really subtle and easy to miss. In JavaScript, they have export. You can either put export in front of functions, or you can do players export, kind of say export.modules or something. I don't know, just put export in front of stuff. Oh yeah, this is what I thought of, export default. And that basically means when you import this module, this is the value that you get, basically. So you just import some file, and that is immediately a class, or that is immediately, you know, an expression, similar to how Zig works, where you just immediately get a struct, a normal thing that you can store and do things with. In general, I'm not. Maybe I want something like, you know, having some sort of import function and then being able to call, I don't know, compute on that. Maybe that should just be some sort of expression returning, I don't know, a module. I think the question is this a single value, or does this, you know, put things into scope? Yeah, that's a big distinction between how import systems work. In Zig, this is just a single value. This doesn't put any, this doesn't mean any more variables are accessible. The part that does that is this part on the left that assigns these two variable names. Yeah. Let's not do that for now, I think. Let's only go with being able to put something in your scope. Yeah. Do I want... I'm actually not sure, to be honest. Should there be a way to, you know, basically import a module and get some sort of value that represents that module that is similar to a struct? Maybe. Maybe not. I don't know what to do with this. I think let's postpone that for now and just focus on that, because I think I definitely want something like this. Just being able to import things and those come into scope. I think I don't want arbitrary, like importing anything from a module for now. You know, I can relax that later on, but for now it should just be like, you know, reading this code, you should be able to see where compute comes from. And yeah, there may be multiple options if there are multiple functions with the same name, if you import multiple compute functions from different modules, and then, you know, this gets resolved via overloading. But you should have some set of functions, some set of options that, where you know this comes from, I think. Okay, right. So let's maybe look at the syntax of this right here in a bit more detail. How do we mark things as public? Having a keyword for that, for like pub by export, kind of like currently we don't have a lot of keywords. We have the module keyword, sure, but that is like very declarative, very in your face. For the normal function definitions, we never have any kind of keywords. And I think this is pretty subtle. So I actually tend towards having some sort of separate export section, maybe. Compute, I don't know. That also gives you a nice summary that could be at the top of a file or something, where you see what kind of things does this even export, kind of like a table of contents, of the content of this file. Yeah, let's do something like this for now. And could do like imports and exports at the top of the file, maybe. Like I think that could be a usual pattern. And regarding syntax, everything is indentation based. So I think you should be able to, instead of doing something like this, I don't know, and maybe let's import the standard library, standard lib call, I don't know how I'm going to call that. But I want to import ints and floats and bools and so on. These may be modules as well. Yeah. These may be modules, so you should be able to do something like this, like int.plus, to import the plus function from within the int submodule of the standard library. And because everything is annotation based, I think you should also be able to do just this. And if there are multiple things, maybe use parentheses, like bool dot, and I don't know, int we want plus, we want minus, we want times, we want divide. Yeah, we don't necessarily need commas here. We could live without them. Also, I do find it kind of weird when you break these on multiple lines. Like I think there should be some way of saying this imports int and bool, and then you don't need this kind of thing. But then basically the dot disappears when you have these imports on multiple lines, which is quite strange. Oh yeah, the int type, the bool type. It is a bit inconsistent, I have to admit. You're having a dot here and not having dots here. But I think that's okay. Yeah. Okay, so you can have imports, you can have exports, and that's about it. Gonna comment this out. And let's maybe create, let's just remove that. Let's create some sort of module hierarchy. So we have a module A, we have an inner module B that defines, B compute, I don't know, or like compute B that takes some value. And yeah, this exports compute B. And then there's the module C that exports, let's call these the same thing, export compute, hell yeah, which is defined here, compute value. And then in this parent thing, can do import .a .compute, and then you can call compute. That's the idea. Yeah, and then in here we can say import dot, oh yeah, this would be B, compute, import A dot do stuff, so that we can do this down here. That seems doable. Yeah. Let me take a quick break. Alright, so let's start with parsing, I guess, and see how we can put this through the compiler pipeline. In the bacon, nothing needs to change because these are based on indentation that's still completely valid. In the toast, however, we need some new stuff. Currently, we just have, let's see, basically a slice of definitions, which can either be a type or a function. And now there's an additional thing, the module. You can declare a module, which will be a toast module, let's call it that. There are also imports and exports. I think those are also definitions, maybe? I'm not entirely sure. Do I want to do it this way, or do I want to say toast module, this has definitions inside. I could add imports and exports in here, maybe. I'm not sure about that. basically, you know, when you write import something, that automatically gets attached, that information to the surrounding module. I don't know. No, let's just leave it like this and have a separate thing for imports. We have modules, we have types, we have functions, and we also have imports and exports. And what does an import have? Oh, it's basically some sort of tree, I guess. Yeah. Import something. Some sort of path. Which would be a toast import path. It has a base thing, that's this front part. And then there are members, I guess. And because this is tree, let's maybe do it like this. Members, and that is and the members also have names. Yeah, I don't know, something like that. And then this could just contain, and we could name that toast import. Yeah, let's call this toast import path, maybe. And an import contains an import path. Yeah, I think that makes sense. So this right here would be an import with an import path where the name is .b, and it has one child, which again is a path with the name compute, and that has no children. So you can, the idea is that you can, you know, do stuff like this. Import core dot, and you want to import something from the int module and from the bool module, and from the int module you want int plus minus times divide. From the bool module you want bool stuff. Now we could use curly braces for that. Maybe that is more a bit clearer, because these import things, they kind of behave more like unordered sets. You know, it's not, it has nothing to, well, yeah, I don't know, parentheses, using parentheses for grouping is also intuitive, I think. Okay, yeah, so this would be an import with the name core with 2 children. One of them has the name int and has many other children with the name int, plus, minus, so on, which then don't have children. Yeah, there's kind of a tree of imports. Okay. And then exports. Yeah, for now, let's say that you can just export a single name, and we can always make it more powerful later on. So this has an import. It can contain imports and exports. Okay, nice. And here we have toast type div. What does that even mean? Yeah, this seems fine. We'll probably have to adjust some of this. So let's compile that, see where it fails. Oops. Oh wait, it does not fail. That does not seem right. Like toast def. At some point we should switch on toast def, I think. Oh, maybe we don't. Yeah, maybe we don't. But let's print the toast. Yeah, okay. So in the toast.mar, in here we switch on the definition. Yeah, if that is a module, we write module and then the name of the module equals yeah, then within that module there can be more functions and so on. Oh, I see. Yeah, the expressions, they take an annotation. And I think we need the same thing for the top level toast thingies. Because these top level functions and so on, they can be indented. And the default one just writes the toast with annotation 0. So this delegates to this down here. And this then switches on the definition. It also needs to print the indentation. So indentation many times we want to print spaces. Yeah, if there's an import, we do something. If there's an export, we do something else. Export is pretty easy actually. Just export and then the name of the thing we export. Import, well, has an import path. So I think in here we'll do import and then import.path. And up here we have the definition.name. Yeah, module needs a name. Module has a name and definitions. So for def and toast defs do. Yeah, and this is something similar to this one. Hang on. Toast def. Yeah. Oh, I see. Yeah, let's make this only work on toast def and instead put this loop out here. Yeah, like this. And print the definitions. Write def with indentation 0. And then in here we only need to care about a single definition, which means that we can also call ourselves recursively. Write that inner definition using the indentation +1. Yeah. That's the definition. From module, reprint the module name. And for each of the module definitions we do something. Yeah, that's more readable. Type. Oh, come on. Yeah. Okay. Cool. Yeah, I'm not entirely sure about this one, to be honest. Having a string in there. Maybe just doing something like b is yeah, I think that makes sense. Which begs the question, how do we refer to parent modules? For example, oh yeah, in B we should be able to import C. Could have some special, parent thing for that, and then you need to chain these to refer to parents way up the stack. That's also weird. Okay, but at least we can do this without strings. I'm not satisfied with this for some reason. I don't know why, to be honest. Yeah, you should be able to do this. Import the sibling module C, the compute function. That puts the compute function in the current namespace, in the current scope. You can use that. And then we also export that compute function. And then in here we import b.compute, putting compute into the current namespace. So in here we can say compute value. Yeah. this would just be import .a .do stuff. What do I not like about that? I think I want some sort of separation between getting the module and putting things into the current namespace, if that makes sense. Yeah. You know, if there's some sort of import of a file, like, okay, later on I also want to support importing the bytes of a file directly. If you have some assets, you know, let's say import, I don't know how that's gonna look like, but if you have some JSON file, for example, you should be able, you know, to have that in your normal directory structure and import that, and this should result in a list of bytes that is compile time known, which you can then do stuff with and parse that at compile time and stuff like that. So I want to, you know, support dots in here in the name of a module, or like a thing. What if I don't know. I basically want a way to, you know, this should be a value that is just some bytes. Now let's call it import asset, I don't know. And similarly, I want something that says this is just some value that happens to be a module. So you should be able to do, you know, x equals something, b equals something. Yeah. Import, and this is some module. And then as a separate concept, I want to support putting things from a module into the current namespace. And maybe that's use, I don't know, use, and this is, you know, this can just be a compile time, this can just be a function call on a compile time known function. Yeah, while this use thingy, that does not behave like a function call. that is something completely different. Here we have, use x dot compute. This is the thing that puts names into the current namespace, into the current scope. Yeah, that does seem kind of bloated, because for the common case of importing something from a module, you don't want to use like import b and then use that dot compute like that. That is horrible. Yeah, so maybe import is a bad name for that, and instead this just this is weird. Like, what is an expression? What is module? Storing modules and variables and so on. It feels kind of weird. It is elegant, less concepts in the language, which is a huge benefit. But this is just strange. I like this though. Like, let's say this is module, this is asset, and these are like built-in functions, but they are normal functions. You can call that function with a compile time known value. You can call this function with a compile time known value, and this evaluates to bytes. This evaluates to some module value. Yeah, and then this right here puts some of these inner things of the module into scope. Yeah. And then later on, if you have packages, this can also be a separate thing. Or like here you can have some URL, I don't know. Yeah, that does seem reasonable. Though the question still is, like, what do we do with this? This would then be, use or import. I think import is fine here, because this kind of imports things into the current namespace. Import module b dot compute. This is this does seem verbose. I don't know. I really don't know. You know what, let me take a walk and think about this a bit, and then, yeah, I'll do something. It is another day, but I've thought about this a bit. And in particular, I figured out that I don't have enough information to decide on a good design. And at the end of the day, this is just syntax, how the imports look. But I have a pretty clear understanding of how I want modules and imports to work. So I'm just going to implement the first solution that I came up with and figure out how that works in the compiler pipeline and stuff like that. And once I've nailed the semantics, once I've implemented that and used that for some bit, once I have this more intuitive understanding of how modules and imports work and what they are like, then I can go and take another look at the syntax of imports and figure out whether there's a way to map that those semantics more easily or more clearly to code. Right. So the first idea was to just, have a string as the first parameter, like import a.compute. Nothing of this sort, like modules are not expressions. It's all just very, very simple. Okay. Yeah. Also, in the long term, I want to allow having modules in the same file, declaring them right here. But really, I mostly do this because I want to be able to split code into multiple files. So I think I'm not going to implement this right now, but only implement the version that relies on multiple files being available. Yeah, this Rust helper folder, I'll delete that. And I'll add another folder for Plum source code. I don't know how I'm going to call that. Maybe Plum. Yeah, this is the Plum code, like the workspace maybe. I don't know. Playground, something. And yeah, here's the Plum code, as well as this core code, sure. All right. Yeah, so test has submodules, which means it's actually a folder called test. And that is inside there and has a special name, something like, mod in Rust or underscore maybe. Okay. Yeah, and then there are these submodules. So I'll have to create files or folders for them as well. So I can import them here. That's the idea. And leaving dot for sub modules and dots for navigating up in the hierarchy. So I'll have a submodule for A. What is PL? There's a camel. Is that Perl maybe? Element. Oh. Okay, so module A contains two other modules. Yeah, sure. Yeah, okay, so that's actually going to be A slash underscore plum instead of this. Oh no. Yeah. Wait, where's my... I think I deleted the code. Yeah, I did. Okay. So the idea was that A has two submodules, b.plum and c.plum. And I don't know, B has some function in here, compute, that takes some int, produces an int, and what it does is it just always returns 42. And B should be able to import that function, so import ... c, the sibling module C, and from within that module the compute function. And then it should be able to export that compute function. So this puts the compute function into scope. I can just use compute down here, and this re-exports that compute as a member of C. So in here I should be able to just import that. Import .c, no, not .dot, because C is not a sibling module. This is the A module, basically the file that corresponds to this folder, you know. This is going to import the compute function and then export that again. Yeah, I will have to think about, you know, renaming these when you import them or export them and stuff like that, but for now, yeah, this is fine. Okay, so in hang on, we need some sort of test file. Yeah, not inside A, but in this test thingy maybe, I don't know. That doesn't work, I can't move that there. This is weird, isn't it? Wait, what? Oh, these are not children of A, I see. Yeah. Okay. Yeah. Yeah, that's more like it. So in the workspace there's a core.plum module and there's a test module. Makes sense. This one is just a file, this one is a folder, and the underscore.plum file within that folder is like the main module file. So here let's declare a main method that takes an int and returns int, and what it does is, yeah, please use 2 spaces. Yeah, it just calls compute with that value. Compute comes from a compute. Okay, yeah, this should work. Like, currently it doesn't, but this is what I want to get working. What's this? Nothing. Okay, remove that. This one, yeah, let's remove that. This one, test.mar. Oh yeah, remove that as well. And remove this assembly file. Okay. Now it's a bit more cleaned up here. Right. So now let's look at actually implementing the code. for modules. Yeah, currently we have these compiler stages, and it turns out we can't just organize the entire compiler into stages. Because if there's a file that imports another file, we may need to, load more code and parse that as well and compile that. So it's not like we get the bacon of everything and then the toast and then the egg and so on. But I don't know, at some point maybe in the egg we see, oh, there's an import there. Well, we'll have to, parse that file again, do this part of the compilation pipeline for that other file, and then for the files that this file imports, and so on. And then at some point, these different eggs from the different modules, they get joined into a single yogurt. So this pipeline is not really one data structure that gets transformed on and on, but it's more like one data structure per file, and then those all get joined into one common compilation pipeline somewhere down the line. Yeah, I'm not entirely sure where though, but we'll figure that out. So we were working on the toast last I checked. Yeah, we won't have modules in here, but we will have imports and exports. Yeah, there is no way to declare module within your code right now, and that is fine, I think. Okay, yeah, so imports and exports. Exports just have the name of the thing that's being exported, makes sense. Imports have a path. Does that make sense? Imports have, my idea is let's do something very simple, and then later on we can make them fancier and support grouping things with parentheses and I don't know what. But for now, let's just use the simplest possible version of this. So an import, I think, just has a module, which is a string. This is hang on. Yeah, that's this part right here. This is the module that we want to import stuff from. And then it has a single name after that. Let's keep things simple and then complicate them later on. Yeah, then the member maybe that we want to import, something like that, or like the name, the declaration. Yeah, because here, like this should also be declaration, I think, or like the semantic. These should match. This should be the same thing that's being imported and exported. Now let's say declaration, even though it's not really definition is what it's called up here. Yeah, import an item, a definition. I think definition is fine. Yeah, kind of matches toast def up here. Okay, so modules can contain definitions, and you can import and export them using their name. Amazing. Now, here we have printing, which got a little bit more complicated. And yeah, we don't have modules. Amazing. Yeah, we don't really need the annotation right here. The annotation is always 0. But let's keep that. I think that makes sense, especially later on when we do support defining modules in code. Okay, so we can import declarations and we can export declarations. And in here, let's put, this is a string, let's put quotes around that and escape things inside, maybe. Yeah. Okay, so what does this say? This is not a variant. Oh, yeah, this is super weird, I think. The errors don't really update for some reason. I don't know how to fix that. Oh, maybe look at that tomorrow. Yeah, okay, but the rest doesn't really change at all. Okay, types are just single line thing. Functions are actually multi-line. Oh yeah, here we'll just write the fun body with 1, and I'm gonna change this to indentation plus 1. Indentation here is always 0, but later on, when we nest modules and so on, the body of the function will be more indented than the then the module itself. Okay, so we got that working. Yeah, currently we don't do anything with that. We don't parse things. Let me go into and compile this. Doesn't work. Okay, compiling format without white space. Variable. String and source. And the toast variable. Okay, so that is variable string. Hey, hang on, what? 135. Go down here somewhere. Yeah, like that's the problem with not analyzing functions unless they are used. You discover a lot of errors once you've once you use them again. Okay, yeah, the call cannot be printed for some reason. I guess that is true. What is a call though? Toast call has a function, which is an expression, sure, and then a slice of other expressions. Oh, this is a type call thingy. Yeah, toast type is defined up here. Toast type call has a name and arguments. Well, so this will be the name and then the arguments. How did this ever work? Did this ever work? Like there are no... That's weird. Anyways. Yeah, writer dot. We'll just format the arg normally. Without white space. Oh, hang on, we do that up there. Oh, I see. I see. Yeah, this should work. Hang on. This should work. So we have this main printing function for types. And down here is just printing without white space. And this is a toast type call. Oh, I see. So what we really want is toast type dot call and print that. Yeah, let's not do that. Let's just use the type dot value. Yeah, and not actually. We only use this as information of whether to put spaces around that or not. Yeah, and we don't put spaces around variables. Everything else gets parentheses. That's what I meant. Everything else gets parentheses. Okay, so. Yeah, args. Oh yeah, this is called payloads now. Sure. ampersand toast type. Sure, let's do that. Toast expression and int. That doesn't work. Okay. Oh, it's an indentation. Oh, interesting. I like that. I really like that. Is that like there was like a helper class, right? Is there like utils, helpers or something? Formatting, that seems, yeah. No indentation. Oh, amazing. So here we'll just say no indentation. And then you can say no indentation +1. I like indentation +1. Yeah, that's right here. And here we'll just do writer dot. That is elegant. I like that. Yeah, from 0 to indentation dot amount. How did that not get caught before? Was this never ever used? Strange. Yeah, there's not a variant of toast expression. Oh. Okay, so toast expression is an enum, no kind needed here. Oh man, this is just fixing of previous bugs, you know, this is not actually implementing modules. Yeah, there's a toast struct and it probably has fields or something for stuff in struct.fields. If there are no fields, and do other stuff. Yeah. Okay. Toast param. Yeah, sure. Param has. Where's that here? Param is a name. Probably. I don't know. Yeah. Oh, that's a string and source. So the name, the string of the name. Yeah. Oh man. Toast var has left equals sign and right. So var, here we actually want the left part. This is the right part. Stuff like that. Toast expression. This doesn't work. You cannot print a toast expression because this should take an indentation. Oh man, writer.right left with the same indentation, yeah. var.left with indentation 190. This doesn't work because this is an ampersand toast expression. Oh man, this is compiled. That's nice. And actually, I don't really have more time right now. I'm meeting some people, so yeah. I just hope this doesn't compile. Of course it doesn't. Oh, because it's workspace. Workspace test plum. Yeah, I didn't get to implementing modules, but I'll do that later on. Yeah, I'll look at that. Yeah, see you then. Alright, yeah, let's look at parsing that, because currently this just fails in line 0, because yeah, it says import, and this is not a valid, definition, valid declaration. So, in the parser, aka the bacon to toast conversion, we want to parse imports. So let's try to do that. How's that organized? Let's see. We have general parsing stuff. We have parsing types. Parsing values. And that's basically it. And then, oh yeah, the declarative parts. This is where the imports are as well. So we have parse type definition, and what we want now is some sort of parse import. Also, let's say we only, let's not support new lines right now. Let's just support this on a single line. Import, then some sort of string followed by a dot followed by a name, and that's it. Yeah, so this is going to be parse import of a bacon, where we create a parser for the line, and then we do parser.consume import. Or if that is not the case, if the line doesn't start with import, we just return no match. No import here, post import. We have no toast import to return. Otherwise, if this worked, if the line starts with import, hang on, I think there's like a consume keyword or something that also checks if there's a space afterwards. Maybe not. Yeah, okay. Because I'm wondering, what if you have a line that says importing is false? I don't know. This does start with import, but we don't want this to be passed as an import. I guess import space. For now, let's do that. Later on, we should, create a more robust parser here. Support importing multiple things in a single expression. Support in a single import statement, supporting more syntaxes. For now, this is very restrictive, and that's fine. How do strings get parsed? Parse string. Okay. We consume this right here. That's perfect. And then until there's a quote, we basically parse that. Okay, that is exactly what I want. So let's just call, package module is parser.parse string. Or if that doesn't work, then we just return bad input, expected string or something. Expected module. Okay. Yeah. Next, we want a dot. So after the string, there should be just a single dot. Or if there's no dot, then return expected dot or something. Expected dot, sure. and then comes the name of the declaration we want to import. And that can be both an uppercase name or a lowercase name. So just, what does this do? Parse type variable. Oh yeah, just checks that parses an identifier. Consume whitespace and then parser.parse identifier. I think that should also be used for parsing expressions, right? Or is that what parse name is what it uses? Which is defined up here, consumes whitespace, and then parses an identifier. Okay, so we don't care whether that's uppercase or lowercase, so we just say parser.consume whitespace and then parser.consume identifier. And that can be both, you know, lowercase, that can be uppercase, that can be symbols like plus, anything goes. And this is the definition that we want to import. Amazing. Yeah, these have to be mutable. And then after all that worked, we basically just return, hey, we passed something successfully. Here's the toast import that needs a module and definition. Amazing. Consume identifier is not parse identifier probably. And that may return like a maybe thingy. Yeah, exactly. So if this doesn't work, then we just return expected the imported definition. And then in here, definition is this, you know, string and source tuple basically. We only put the string in here, which means we can't attribute imports back to their location later on if there's a compiler error. So what? You know, that's fine for now. Same happens here. What's going on? Field module, exactly. Oh, so this is a result. I see. And then if there is no thing, then we do this. Module is module.string. I see. Okay, and then parse export will be pretty similar, actually a bit simpler. Because we don't need to worry about the module. We always export from the current module. So this part is just not there. Just export and then the exported definition. Returning toast export of this definition. Something like this. Okay, and then these should be used at some point. Not entirely sure where. Well, this returns a toast. So we have definitions. Yeah, and we try to parse several things. So what we do here is if bacon.parse import, and if that is some import, then defs push toast def dot import of that import. Similarly for the exports. And here as well. Yeah, true. see. Let's see what happens. Okay, this is unfortunate, I would say. Still doesn't work. Okay, expected. What is that? Fun definition. We parse a function definition by parsing a name. So it probably treats that that import as a function, which is not exactly what we want. Yeah. We're not trying to define a function called import. Oh, hang on, there are continues here. That is quite important. Right. Okay. Okay, that is nice. We have the toast. That is actually pretty amazing. And now an error occurred. Compute doesn't exist. Exactly, because imports don't do anything. So let's fix that. Let's try to fix that. Yeah, but the bacon and toast is totally fine. Next comes the egg, I think. And there should be some toast to egg. Yeah, conversion. So in the egg, we don't... I think imports should just be... Well, let's read through this maybe. Representation of code that is simplified and more suitable for type checking. Okay. So we have types and names of types are resolved. Oh, types have no names anymore. They're completely structural. Yeah, this is kind of difficult to do if the type is defined in another module. Well, that kind of sucks. I'm not sure what to do about that. And then functions, well, names of locals and types are resolved, yeah. Function calls are not resolved to specific functions yet, as this requires overloading resolution. Nested expressions and function bodies have been flattened to a series of small expressions. So we can do that without looking inside other modules. Now, if you have some nested function expression, we can flatten that to a series of more fundamental ones. But this one is difficult, and this is an example of where it makes sense to sort out imports in the compilation pipeline and not delay that until like the end, you know, when the language already works. Because when modules, imports, and so on are resolved, that can really determine how you structure your compiler pipeline. So it's good that we do that right now and not delay that any further. Yeah, types might have to change, to be honest, so that types are not resolved yet. Oh, on the other hand, we could also say that in the egg, we just, we parse all imported files as well already. That would be, that would actually be doable, I think. Yeah, no longer have any imports here, and just have everything in a single egg. Types no longer exist because types exist, but types are not nominal. Types don't have names, they are just structural plant types already. And all the functions in here, just all global functions appear in here. Yeah, let's do that. Alright, so in order to do that, we kind of need a way to, first of all, make it so that you can execute the first part of the compiler pipeline again later on. Like this structure here doesn't work. We can't just parse the entire workspace and then compile that. What we want is to only read this specific file, and then based on the imports, parse that file and so on. But then based on the imports in that file, we want to do this part right here for other files as well. So that at the end we have the toast for every single file that is imported. And then from all these different toasts, we can build one unified egg. And the other compiler stages, they don't have to care about modules and anything. So the question is, how do I do that? First of all, I think that's, in many places we have, oh no, an error occurred, and then we exit. I think it makes sense to separate the actual compilation pipeline out into a separate function, just return an error, and then, handle that error in the main function. So we want some sort of compile function that takes a file name, which will just be a string, and it returns the bytecode. The bytecode, waffle to bytecode, is probably some sort of bytecode. I don't know, it's just an address. Well, that is kind of cursed, maybe. I don't know. But sure, this is just an address. Then what we do is basically this. Boom, we cut that alt and we paste that in here. And we return a result that may say, something's wrong. Do stuff about that. Okay, so we read this file, and then up here we just say bytecode equals compile this file, please. Nice. This is pretty cool. Oh yeah, and these error handling cases, hang on, these right here, they happen up here. And this should probably be like an actual type error, which means this returns couldn't read file, and it needs source location, I think, which is cursed. Yeah, I know. Let's see. Invalid source. Well, sure. Invalid source. I like that. We could just do that. I just convert that to a constant instead of a function, but I don't know. Later on, I'll change that, maybe. Okay, yeah, inconsistent return types because of course we return an error of an error instance. And this is, yeah, these are two different error functions, both named error. Is that cursed? I don't know, maybe. Oh, this always works apparently. Or like this, I think so. Yeah. Well, this is easy. This is actually pretty amazing. Yeah, and in the end we just return a successful address. We could even simplify this further. Hang on, the egg. Where's the egg? Toast to egg. This is the compilation pipeline from a very high level. We could even chain these, like just do content dot to string dot to bacon dot to toast dot to egg dot something. But actually, I like doing it this way, so I can more easily add debug statements if I need to. Yeah. Okay, expected result. Yeah, that should be fixed. I don't know why the tooling is so weird today. Okay, but up here we just say compile that file. And in between here we need to do something. We need to get all the toasts basically map from, I don't know, file name to toast or something. And then pass toasts. Entry point is a string. Result. Okay. Yeah, I want something like this. We build up a map of all toasts. And then this part of the compilation pipeline, we want to redo this for every imported file. So it's actually going to live down here. And we call that part down there from up here. So here we say parse toasts with the file name as the entry point and toasts as the output map. Parse toasts, yeah, that is, let's put a question mark there. And this is the entry point, of course. Yeah. And you can see that here we have the toast. And now for each import in the toast, we can call ourselves recursively. So for each, I guess, definition in toast.defs, do if def is import, and then, you know, here we want to resolve module, and we're just going to put a to-do in there actually. And that module, we want to reparse that. And maybe for, like, you know, to avoid infinite parsing of circuit imports and stuff, let's also add if out contains entry point, then we just return. There's nothing more to do here. Yeah, and okay of nothing. Hello. of nothing. What we do is we pass the file content, we pass the bacon, we pass the toast, and then for every import in that toast, we also pass that file. So after calling this, this should contain all imported modules as well, a map from all required modules that are somehow involved in the compilation mapped to their toast. And here we should just be able to do toasts dot to egg. That's great. Okay. Let's compile that, see what happens. Yeah, this should be nothing, sure. Last expression doesn't match. Okay, because we probably want to return okay after everything succeeded. Okay, this is the signature to egg. Well, true. I want to get that to work, so I'm just going to put it to do in here. Rest of the pipeline. Still need to do that. Okay, yeah. We compile our entry file, this right here. And now it says, well, we need to resolve .a. Boom, because something from .a is imported here. That makes total sense. So now we kind of need to map. Well, we have the entry point. Well, let's call it file name. We have the file name, and we have the module, which is always a relative module. And we kind of need to turn that into other file names. For example, if our path is this right here, and we import .a, there are actually two places where that can be. There could be an a.plum file here, and we want to import that. Or there's an a folder, and there's an underscore plum in there. So there are two places where we have to look, basically. Let's say resolve module file, I don't know. Base file will be a string, and then we have the relative import, which will be a string, and this returns a list or a slice of strings. And I think the first part we want to do, what do we want to do? You know what? Let's actually not have this in here. Let's just say compile accepts some sort of path to a plum module. And that can either be a file, test.plum, or it can be a folder directly. Yeah, there needs to be some sort of definition, like which one is preferred in here, but yeah, I think that makes sense. So resolve module file. It's all just strings as types. That's weird, but it's, I guess it's fine. Yeah, okay. What do we do? We have a relative import, so we check how many parent navigations are there. Okay, you know what? Let's maybe create a new type for that. Some sort of module type or something. Yeah. I think it makes sense to create a new file for that. Module.mar maybe. With a struct module, which just has a path. Is that a string, or is that a slice of components or something? Like this could be, basically splitting it at slashes. And then you can more easily add things to the path and remove them. You know what? No, I'm gonna leave that as a string. And that's it. Simple, and manipulating these module paths is more difficult, but that's fine. Okay, so this functionality that works with that is also down here. So resolve module import, we have a base module, and we have a relative import, which is a string, and this gives us a new module. That's the idea. And then we have some sort of file paths of some module, giving us this slice of possible file paths for that module. And let's maybe do this one first, because I think this will be pretty easy. We can just, we have the path. There will be two options. Either it's just the path dot plum, or it is path /_ dot plum. These are the two possible options where the file corresponding to a module can be. That can be a file, and that can be a directory containing an _plum file. And then resolving imports is, how's that going to work? We check how many parent navigations there are. Start at 0, and then, basically we loop. And if relative import dot starts with dot, then we do two things. Relative import is relative import without first one character or something, like substore 1 to relative import dot one. I don't know, something like that. And parent navigations is parent navigations plus 1. Yeah, else we break out of this loop. Amazing. Then we've figured out the number of parent navigations. And all that's left is the the actual name of the module we want to import. So in here we can do we can do base.path.split /. This will give us the components or something, whatever it's called, of the path. And then components without the last parent navigation is -1 components. Oh yeah, we should maybe check that if parent navigation is equals 0, then this might be, later on this might be a package import, maybe something like import call, I don't know. And relative imports always have at least one dot here. So if this is the case, then that's actually an error. That's which means this has to return the results. Amazing. And from here we just return an error. Can't import, I don't know, something. Packages yet. Yeah. And here we take the last, if you have many dots in here, basically we want to navigate up in the directory structure. We want to navigate up this number of folders. We want to actually navigate 2 folders up. Yeah, so it's always parent navigations -1. And then those get joined again. So yeah, these, join them using a /. That will be the new path. And then we say, okay, we have a module. And this is the module's path. So that's resolving imports. Oh yeah, string doesn't exist, so let's import the plum main file so that the standard library is imported. Okay, path is not in scope, that makes sense, because this should be module.path. Yeah, module is in scope. Okay, so in here we can actually pass toasts if that already contains, oh hang on, no, this will take some sort of module. And we should maybe have a module constructor accepting the path just for brevity, which will return a new module with that path. So there's a compile some module. Look at that. Oh, and there's a map from module to other stuff. Beautiful. Parse toasts. And that parses the toast of this module itself and of all required modules, or all imported modules. Yeah, and here reading the file is actually a bit more involved. So we have a string in the end, and then basically for each path in module.filePath, we try to read that file, or if that doesn't work, we just continue to the next one. These are the bytes, and then we say content is some bytes and please break. And then here we say content is content, oh hang on, some bytes to a string. here content equals content, or we return an error couldn't read file. Yeah. So now we try all these different paths in B, and we prefer normal plum files over directories, which is fine, I think. I don't have a preference there. True. Oh, I might need to adjust error later on. Because once we support multiple files, multiple modules, well, okay, so compile doesn't work. Interesting. This call doesn't work, compile string. Oh yeah, true. Because now you can only compile modules. Let's actually change this as well. Now we have this module dot compile. Beautiful. Oh yeah, hashing modules is, they are the key in the hash map, in the toasts hash map. And here, and here. So modules need to support hashing and equality. So given two modules, are they the same? Well, we just check if their paths are the same. And hashing a module using some hasher and a module would mean we just hash the path. So hash dot hash and module path. Oh yeah, hasher. Oh yeah. Now we can do this. Now we can you know, do module dot we take our module and then we say resolve import and the import module, and that gives us a new module. Otherwise we return an error. Please work. No, doesn't work. Yeah. Sure. Well. Yeah, okay. All of that doesn't work. Then we return an error with that message, and for now an invalid source, but later on we might want to highlight the specific you know, the specific imported is this module. Okay. I don't know. And then we pass that imported module as well. So imported parse toasts using that same output map. Yeah, this is, oh yeah, this is supposed to be a string. Plum 86 module.resolve module return error. Oh right. Okay, yeah. If def is import, then we do this. This parse toasts, yeah, returns result. We may need to, yeah, if that throws an error, we also want to throw that. Okay, seems like it's stuck in an infinite loop. Not quite what I want, but sure. Markers are not printable. So let's add some sort of divide method here. We just reparse the test again and again and again and again. That is weird. Oh, I mean, we never put anything into the output map. That might be useful to do. So out.put. We just save that toast in there. Okay, parsing workspace test. That is exactly what we want. But why doesn't it parse? Yeah, that's horrible debugging, but yeah, parsing this. But this imports module A, so I would expect for it to then parse the other file. Hang on, we have an import, and then we resolve that import. That probably does the wrong thing. Resolve import. What we do here is we remove the last. Well, okay, yeah, that is. We remove parent navigations, but then we also want to add a relative import. You know, the remaining one, the dots have been cut off up here. Yeah, not quite, but almost. So the path will be the. Yeah, let's do that like this. Amazing. I don't even know how to format that elegantly. Maybe there is no way to do that. Yeah. So it's the base path, split at the slashes, removing parent navigations, then joining that. And then after that, we put another slash and the relative import itself. Boom. Hell yeah. Okay, so we are parsing workspace test. We are parsing workspace test A because that is imported. Crazy. And then we actually parse that file. Okay. Workspace test A, I think. Like, shouldn't that import other stuff as well? Oh. Oh, there was this. It parses this file because that is preferred over this folder. And now it should import. Yeah. Oh, amazing. Honestly. Parsing workspace test A. This one. And this imports .c. So we're also parsing workspace test AC. Workspace test AC. This one. Oh yeah, this is supposed to import B. Amazing. So now it imports parses B. And here there's a compute function and then stuff. Okay. Yeah. Now we need to implement the rest of the pipeline. But this part works. That's pretty cool. Yeah, let's remove the debug prints here. And now we have all the toast. We have passed all the modules that we need for our compilation. And we want to put that into a common egg. Okay. Yeah, parsing these toasts into an egg is the next step. Toasts to egg, and this doesn't work currently because toast to egg works on a single toast. It should work on toasts, which is a map from a module to the corresponding toast. Create built-in fun. How does that? What does that do? Hang on. Funs.push. Create built-in fun. So this very much looks like what you need to do for every single toast, which makes sense. So let's maybe, yeah, let's not change this right here. Instead, let's add another function that can also compile a map of toasts. And this is the one that actually creates the list of all functions. So what does that actually do? For each, like for every definition, it pushes something. It pushes an egg fun with a corresponding name, with parameters, with a return value, and with a code implementation, where it kind of tracks which variables are visible and so on. And this will have to be adjusted to account for imported stuff from other modules. Okay, so now we want to convert a single toast to the egg. I see. Yeah, how do we do that? To egg of toast. I think it'll be similar to what we did here. You have some sort of out map, out list result thing. This list of functions. So we have, a list of egg funs. That's the output part. Let's really call that funs because why not? Yeah, and here we just push things to the functions. We don't need this ampersand for that. then you say convert that toast to, you compile that. So basically for each entry in the toasts, we just do entry.value, which will be the actual toast, to egg, outputting that to funds, and the funds is what we return at the end. Hang on, yeah, something like this. Because this actually returns a result of nothing. It doesn't need any return value. And that means this is just nothing instead. Everything succeeded, and that's everything it needs to return. Okay, yeah, so up here to egg, we have last expression doesn't match. Well, now it does. The hints just don't update for some reason. Assembling. Okay, that worked. Wait, what? But I mean, we don't have namespaces. We just, but it does work actually. That is crazy. You know, we say import a. Yeah, like this part down here is not even used. But this just causes A to be analyzed, which causes C to be analyzed, which causes B to be analyzed. Oh, there's a compute function. And here we call the compute function, and all functions are just in the same scope currently. But still, that's, you know, that's progress. Just being able to import other files and having those functions in scope as well. That's actually similar to how Martinez works. In Martinez, you just import stuff and everything is in the same namespace. Like you just import files basically. Yeah. So now comes the interesting part, or the the novel part, I guess, which is tracking the visibility of types on a more granular level. And the way that works, I'm not actually too sure about that. Toast to egg, this is where that is. Let's see. Functions push egg funds. Okay, the implementation, we create a new visible thing, which is fine because I think that's only for yeah, tracking variables which are in scope, not functions, etc. Let's see if that's correct. Yeah, name binding is a string and egg ID. Okay, yeah. Okay, that is pretty cool. Yeah, and function calls are resolved later on. That's why it works. Okay, so it doesn't work for types, for example. Right, if I have, I don't know, import .a.foo, and we say this main function actually accepts a foo, and here we say that, by the way, foo equals int.
we export foo, this won't work. No main function, because foo is some type, something weird. Let's maybe do it the other way around, I guess.
No main function, interesting. I don't quite get that, to be honest. Well, but what I would assume happens is that we have these egg parameters, and then we say type param.type.toEgg using our toast. And even if we import types from other files, like those are not really accounted for. Here we just say type to egg, and that's down here, and that says that's a call with some name. We lower the argument, we handle the built-in types, and then at some point we have we look for a user-defined type. That's basically it. We look at the toast definitions, and if there's a definition with that type. Yeah. So that is weird. And there is none with a correct name. So I think, like, actually this should, why doesn't this error appear? No main function. Where does no main function come from? Anyways. Egg to yogurt. Look up main of int. I don't know. I don't know why that happens. Okay. Anyways, I think what we need to do is, when converting the toast to egg, we also want to check which functions, which types, etc. are in scope, and kind of aggregate them before doing other stuff. So yeah, we have variable scoping, and here we have the actual compilation. Compilation, I don't know. And then in here we have imports and exports. I think we need some sort of give me the exports of a module. And you can only export names.
And each of these names is some definition. Does it make sense to disambiguate between type exports and function exports? I don't know. Probably not. Okay. Yeah, the exports of a module, of a single module, module like this. Yeah, there's not a result. This is a map. That's what I meant. A map from strings to something. Yeah. First, it's an empty map. And then we'll just go through the module definitions. And if the definition is an export definition, it just has a name, I think. So the name is export.definition. And then we have, well, okay, we also need the things that are in scope in a module. So given a module, and these kind of toasts, which definitions are in scope? Yeah, within that module, you know. And these should be the definitions defined within that module, as well as the definitions imported from other modules. Yeah. Yeah, and there can be multiple with the same name, because yeah, this should really be a list, and this down here as well. And then for every definition in the module, in the toast.get module returns the toast, and the toast has definitions, and for every definition we check I'm going to take a break.
Here we are. So devs in scope. We go through the definitions within the toast. Okay, yeah, that makes sense. And then basically we want to switch on what kind of definition that is. Yeah. You know, if that's a function that is defined, then we add the definition to the defs. So this would be defs.push def. Yeah. And if it's an import, well, no, this is the interesting part. I'm gonna put it to do in there. Export is irrelevant for seeing the definitions within the scope. Yeah, and then the types. I do handle that, yeah. Okay, I don't need the payload because I'll just append the original definition. For imports though, I basically want to follow the import. Yeah, so this would be import.module yeah, I know. That is a string, yeah, and then we resolve that relative to our module. What was a module? Resolve something. Resolve import. That gives us the new module. And then we say what are the exports of that module. And by the way, here are all toasts. So exports of imported module equals this beautiful variable name. And then we see which of the declarations there is imported. So import dot the definition, I think. Yeah. Import of definition is a name. And we do exports of imported module dot get that thing. Yeah, and well, basically I'm not sure. Exports of imported module dot get the definition. Yeah, that would give us a toast definition, and we push that to our devs. Okay, yeah. And in the end, we return the devs converted to a slice. So this is not really a list, but a slice. Same down here, where we build a map of exports. And yeah, basically for each of the definitions in the defs that are in scope. Defs in scope is module.defs in scope, given the toasts, and then for each each definition within the module we check if there's an export. Then we have the name. Yeah, we basically do exports dot, oh yeah, this is supposed to be a list, which at the end of this function is converted to a slice. But what we do is we push a new definition. And what definition? Well, devs in scope dot, okay, true. If I have some module and I import some functions, multiple plus functions, a plus function that works on integers, a plus function that works on strings, and then I do export plus. I actually want to export both plus functions that are in scope, I believe. yeah, that makes sense, I think. So this would be exports.push, export.definition. Yeah, so we basically want to iterate over the definitions that are in scope. And if the definition name, does that exist? Hopefully it does. If that is the export definition, we don't need underscores here. That's not a keyword in Martinez. If that's the same, then exports.push that definition. Okay. That's it. Oh, and same here. If a module exports multiple, multiple definitions with the same name, and we import some, I don't know, core.plus, that should import all plus functions. So really, we, same as down here, we iterate over all the definitions in the exports. Yeah, and if the name matches, then we append the definition. Amazing. Okay, so this doesn't work because this is a result. Well, yes. Yeah, this entire thing should return a result. Okay, so senseless error messages. I don't know why. Okay. Yeah, here we can use the question mark. That's what I wanted to do. And this should also return a result, I think. Because this can fail. Yeah. That seems correct. Oh yeah, this can fail as well. Oh. So this results in a result of string. Well, yeah, I'm not going to call them exports of imported module, but hang on. Okay, I want to return an error. Slightly boilerplate, and then actually construct an error with the error message. Oh, good. Okay. Yeah, exactly. Okay, so this call doesn't work. Yeah. Yeah, not every definition has a name. Because imports, for example, don't, and exports. And that returns, I don't know, maybe string.
which is on the definition. If it's import, nope, no string there. Same for export. If it's a type, well then we return the type name. Is that a thing? I don't know. If it's a, what else is there? A function, then it's the function name. Oh yeah, that's string and source, so this, we only want the string. For now, at least. Yeah. Error attribution across modules is kind of, we'll get to that at some point. Yeah, export is not a thing because this should be import. We look for the matching import. Yeah, let me open a terminal and well, I should have that here, yeah. Let's see what happens. Oh no, an error occurred. I'm not entirely sure. Wait, but that looked like no main function. Let's maybe print the, oh hang on, we don't use this, right? We don't use the imports and exports. I see. I see. So down here, where we compile the toast, what we really want is to sort of I'm not entirely sure, to be honest. So for every definition in the toast definitions, if that's a function, then we push a function here. Okay, sure. Converting a type to an egg not only depends on the toast, on the current toast, but also on other toasts, for example, for imported modules. I think we want some. We want to find out which definitions are in scope. So here, entry.value, that is the toast. Hang on, let's see. Entry.key, that's the module. Dot defs in scope given the toast. And let's just print them. In scope at at the module entry.key
true, and then you have in scope. Okay, 66 is an error. That was in scope. For thingy in module.defs. Defs is not a field on module. That is very true. Now this should be devs in scope, I think. Oh no, this should be toasts.get module. That is a toast, and the toast then has definitions. Okay, yeah. Oh yeah, true. These name calls, gotta unwrap them because we know that the exports don't contain imports and exports themselves. They only contain types and functions. This how? Yeah, this as well. Okay, yeah, this is, let's wrap that in an okay of slice toast def and arrow, and same up here. Okay, compiles. That's the first step. And now let's see what. Okay, so we have stuff. We track which definitions are in scope. First of all, at workspace test AC, here, no definitions are in scope. That's already wrong because we import compute. Well, AB, let's see, that's like the most fundamental module, I think. Yeah, this just has a single function called compute with stuff inside. That's beautiful. So here that doesn't work. For some reason. Why though? Okay, so we have this toast to egg. Let's see, what are the things in scope at the B module in this module? Oh, the C module. Yeah. So we build up these definitions, and the only two there are is an import and an export. So yeah, we never push things to the definitions using this down here. Yeah, the export we do nothing. For the import, however, what we should do is get the resolve the import, the module, which I think we do, because we also see that this module is analyzed. And then we ask, hey, what are your exports? Maybe I should print them as well. So what we do is we check what definitions are in scope, and this will, for the B module, just be the function, like we see here. But then we also go through the code of the module. Oh, yeah, we don't export this function. Oh, it just doesn't complain up here. That is, you know, like technically correct, I guess. Match something false. You know, we import all definitions named compute in here. But there are none, because this is not exported. So I believe this should be an error. You should always have to, like, if you try to import some name, then should always import one or more definitions. Okay, so for every definition in the and then if we haven't matched something, then we return an error. Let's just copy this. An error saying try to import unmatched something. No, try to import, what is it, import dot definition, but that is not exported. Oh, this is a horrible error message translation. This needs to be tied to a specific location, but yeah, again, error reporting, not the focus of this right here. Oh, look at that. Error, no main file. Hang on. In scope add stuff. These errors, they get bubbled up in a really, really weird way. No main function. What the hell? Okay. In scope add workspace test. Yeah, let's bubble them up. I think that makes more sense. Okay, yeah, try to import compute, but that is not exported. We have no idea where that is coming from. But at least it is an error. So what we want to do is we want to export the compute function from this module. Oh, look at that. Things work out. Oh, by the way, if we export something non-existent, that should also be an error. So I think we'll have to do something very similar to this. Down here. Yeah, try to export that, but that is not in scope. Amazing. Oh, try to export compute, but that is not. That is interesting. That is interesting. I would have expected something here. Like in scope add workspace test. Now let's go with the smallest one. C, I think, or B. B. Yeah, we have a function called compute. That makes sense. Then in AC, we also have this function called compute. And that is in scope because we import that. Then up here, we do stuff. Oh yeah, here the compute function is also in scope, as well as the foo type. That is great. And then at the general test thing, the function is imported, so it is in scope. Nice. Yeah, the exports are not really working for some reason. Let me check which definitions are in scope. I don't know. That is not in scope. The only things in scope. Yeah, but it makes sense. Let's build up a more write a string. So we create a string builder, and there we try to export something, but that is not in scope. Okay, the only things in scope, and then for every defs in scope, we push that to the string. So this would be def.name. Yeah, and then we return the stringified version of the string builder. Try to export compute, but that is not in scope. The only things in scope, compute. I see. Sure. Oh, well, okay. Yeah, we should set that to true at some point. Well. This is pretty great. Okay, so we correctly figure out what kind of definitions are in scope within every module. So, what else? Now we need to use those definitions to resolve things instead of just relying on the entire toast. Yeah, so that's also passed in in scope. Should be a list of toast definitions, and that's a separate thing from the toast itself. Okay, and for functions like this, where we convert a type to the egg, usually this shouldn't take the toast, but yeah, these shouldn't take toast, but basically a list of things that are in scope. And that will be a slice of toast defs. And similarly down here. Yeah, and at some point this relies on toast. Yeah, arg to egg. Check the things that are in scope. Primitive things, yeah, this will just iterate over the definitions that are in scope and look for a matching one. Okay. Line 100. Same thing. Hang on, where's that? Line 100. Oh, that's up here somewhere. Oh, in here. Oh yeah, we have the funds as the output part, and then we have the slice of definitions that are in scope. Yeah, 118. This is supposed to work on this, on the things that are in scope. Amazing. 3, 3, 4. All right, when lowering, or here when compiling the function body, we use an egg code compiler of the toast. I'm not sure what the egg code compiler does. It creates an egg code compiler. Sure. And then at some point there should be, we have an egg body compiler that has an egg code compiler as the parent. And here are things that accept the egg body compiler. Makes sense. And at some point this should access the toast, right? Here. Oh yeah, when converting the type to egg. This is the only place where the toast is used. So instead, let's store the definitions that are in scope. Which means, hang on, where were we? Down here. Yeah, this just stores which definitions are in scope. That's a slice of toast defs. And then in here, this is in scope. This is again a slice of toast defs. And yeah, that's basically it. Up here we have to instead pass in the ones in scope, and then in here, let's see, imported module. Module.resolve import. Oh, what's going on there? No, just back on the tooling. Okay, it compiles. Okay, now that is pretty cool. We track which variables are in scope. You know, this only compiles because we import foo, we import compute, and foo is resolved from within that module. If we comment one of these out, it's going to be like, oh, I don't know the type foo or something, hopefully. No main function. Well, what does that even mean? If we comment out the compute thing, it's going to be like, hey, what is compute? Hopefully. It just works. Okay. Well, this is unfortunate. In scope it workspace test. Yeah, foo is in scope. I see that. And it's just int. That makes sense. Then there's the main function. That calls something, sure. And it calls the compute function. Oh, I see, because functions are resolved later on. I see. Currently in the egg, the egg doesn't have types yet. It's not supposed to. In the egg, we just have basically a transformation of that syntax stuff and scope handling. But function calls, they just have a string as the function. And that doesn't work with the scopes that we have. So really, this should store like a
I don't know, a possible an array of functions, something like that. An array of possible functions that could be called here.
And those will be all functions that are in scope. Okay, so a call, let's see, one of a set of functions. I don't know, that seems, one of is a weird candidates maybe. Much better. Well, this is the question, actually. Like, how do we... Hang on, and here we have a list of egg funds. Yeah. But later on in the yogurt, we just have a map of yogurt signature to yogurt fun. And this can't work. Because the signature, it contains the function name and the types of parameters, but you can have multiple functions with the same name, the same parameter types. That is allowed as long as they are in different modules and you don't, sometimes you, in one part of your code you use the one version and the other part you use the other function. That should be valid code, that should be legal. So we kind of need to include the module as a part of this signature, I think. Yeah. And I think there is no good I don't know, no good way of matching that. I don't know, like before this was just a string. In the egg, should functions have unique IDs or something like that? I'm not sure, to be honest. Maybe that makes sense. Additionally to the name and the params, also store from which module that function is coming from. Yeah, I think that is fair. So this also stores a module. Okay, now we actually have like the module and the name, and then we have the parameters and the return type, and then the implementation. Okay. Okay, so let's see. In the toast, and here, no, not the toast, and the other part, the toast to egg. Yeah, when we construct a function, okay, I see. I need to fix this first. So this makes sense. And then in here for the call, instead of this being just a string and a name or something, instead of this just being a string, we actually want function candidates, which will be a module and a name. Do I just use a tuple for that? Maybe module and string, Yeah, I think that's fine. And then for the built-in functions, I think I want some sort of built-in module, I don't know. Module built-in. I have no idea. What's going on down here? So we have some sort of call, and that is a name. Then we look up which names are visible. As local variables. If there is one, that's a lambda call. If it's not, then it is an egg call. Yeah. But now we actually want candidates. And what we do is we actually go through the variables that are in scope, which would be body dot parent dot in scope, list of all definitions that are in scope, and all definitions with the matching name can possibly be it. However, this in scope thingy doesn't track which module those definitions come from, which is unfortunate. So I'll need to adjust that as well. Oh, beautiful. Yeah, devs in scope. Okay, so this is a list of toast defs and exports as well. Let's maybe instead create some sort of def in scope thing, I don't know, that comes from source module and has a kind. And that is either a type, like a toast, or it is a function. Yeah, because this doesn't quite reflect the types. The definitions that are in scope, they cannot be any definition because they cannot be an import or export. They can only be types of functions. These others, imports and exports, they get filtered out. Only types and functions are the ones that get matched there. So let's make this more specific and say this returns a def in scope. Yeah, and for types and functions, we just do the obvious thing. We say, def in scope, where the module is the current module, so this one right here. but the kind is different. So the kind is def in scope kind dot type of that type. Yeah, and we'll have something similar for functions. Okay, so we always associate these functions with the module that they are defined in, and we no longer have imports and exports, only types and functions. And we'll use the same type down here. So then in here, when we look for exports, no, we don't have to do exports.name.unwrap or something, because that name doesn't have to be defined on toast def. No, there was name defined on def in scope, and that always works, because it cannot be an import and export, it can only be a type or a function. And these always have names, so in here we can just do dot name and same down here. Okay, that's beautiful. Mm-hmm. $39. In here we have a type which is a toast type. Yeah. Oh, is it? Or is it a plum type? No, I think this should still be toast stuff. Yeah, what was it before? Before these were just toast defs or something like that. How is that defined? Yeah. Oh, toast type def, not toast type. I see. Yeah, sure. Oh, okay. Mm-hmm. Yeah, and scope should not be a slice of toast defs, but instead defs in scope. Oh, hang on, a slice of def singular in scope. Yeah, try to assign string to field module of type module. Toast to egg 241. That is very true. This is a module. Mm-hmm. Yeah, here we just switch on the kind. Yeah, sure. And module field is missing. And here, indeed. Yeah, converting toast to an egg. Yeah, we need to know the current module. Yeah. And here we know the module. Like this is just entry dot key. Yeah, let's maybe store these. I think that's more clear. We have the module, we have the toast. Oh, yeah, there's entry key. This is entry value. And then we say module depth and scope. Yeah, that seems fine. Okay. Oh, okay. Next compiler stage actually. That's pretty good, pretty great. So read for one. Oh yeah, and an egg to yogurt. Yeah, we have a call, and then we don't just have a name, but we have a list of candidates. And the name is only used down there. Yeah. Let's maybe move that down here. I'm not actually sure. Do we just want to regardless of this lookup that we have, how do we just pass in call.candidates? Probably. I think so. So we kind of need to adjust the lookup function. It shouldn't just take a name, but a list of candidates, which will be a slice of tuples of a module and a string. Okay, and yeah, we look for functions with a matching name and matching module. Oh hell yeah. Thunder module equals, oh, hang on. These should all have the same name. Oh, okay, can you rename functions as you export them and import them? Maybe? I'm not entirely sure. Oh man, there's so much complexity in modules and namespacing. I wouldn't have thought that. You know, coming from, you know, like in Zig, for example, you just don't care about that. Modules are just structs. The fact that these are more like declarative things really complicates things on like a very fundamental language semantics level. But it is required for overloading. Okay, so here we just go through the candidates. Yeah, and instead of looking at the name,
instead of just looking at the name. We also have to look at the module and see if that is matching. So we can do fun.module. Well, yeah, this is kind of weird. Like every candidate already refers to a specific function in the egg. It is inefficient to go through them again, but I mean, let's do that. Yeah, okay. We can always make things more efficient later on. So for every candidate in the candidates, we want to find the function that corresponds to that candidate. So we check for every function in the egg if the fun.module equals the candidate.module and the fun.name.string equals the candidate name. Yeah, that's it. And what I mean by making this more efficient is that, oh true, it was just A and B, yeah, is that currently the egg just contains a list of functions. It would, for example, make sense to instead have some sort of map where the key is basically something that uniquely identifies a function, whether that's just a random string ID something, or the candidates could just be an index into the functions list from the egg. I'm just not sure whether we can do that in here directly. I don't think so. Yeah, to do that we would kind of have to decide up front which function gets mapped, in which order do we visit all functions of this toast and the imported toasts. And once we have that, we can use that stable sorting to save candidates directly. And there are things we can do. That's all I'm trying to say. But here we don't. Here we just take the naive approach and then, yeah, to do, make this performant. Okay. Yeah, and if once we've found the function, we push that to this list, and then if there is no function, we just do that. Okay. That seems reasonable. Yeah, I don't know, there is no matching. Bad error message, but what are you gonna do? Okay, so in egg to yogurt, we look up on the egg a function with a name and a slice. Yeah, so how do we fix that? Egg to yogurt. I think that's in here, the egg. We kind of need the main module, right? So there is a lookup function that takes this right here. Yeah. So let's put a tuple in here of some module, and main. And now it should just say, hang on, a tuple, oh, it's a slice of tuples for the candidates. Of course it is. We have that, we have the arguments, and this is supposed to be a slice, so list. Okay. Yeah. Egg to yogurt. here there is no function. It is kind of weird that the name is separately saved for each of these. I'm just going to save the name here. There should always be at least a single candidate. So candidate start first. Is that a thing? Hopefully. There is no function named name, and yeah, that gives us a tuple, and then we can access the name of the tuple. Amazing. Okay. Now line 850 something. There is no this. That is very true. That is very true. I think the egg should store something like that. Just the name, you know. Sure. And I know we had that in there before, but now we'll just save the candidates as an additional information, which is fine, I think. Yeah, and the toast to egg means we have to adjust that in here somewhere. And the egg funds, they just have something like here. Yeah, this is, we also need a name, which is string and source. So that immediately works. Okay. True. 8 something. Yeah, down here, this is the call.name.source. Okay. Very nice. Okay, no main function. That is true because it looks for a main function that is in a module named module or something like that, which there is no function because that module doesn't exist. Instead, what we want is to have the main function of the like main module. So I think we'll just save the module in the egg, like the main entry module, I don't know, something like that. Yeah, and this is basically the file that you want to execute. When creating the egg down here, at some point, we create an egg. Yeah, and here we have to put the module in there, yeah. And the main module doesn't exist here as well, which is weird. So let's also pass that as an extra parameter here, and in the main file in here pass toasts hang on, no, that just call ourselves recursively. Yeah. Oh yeah, this is the interesting one. Parse toasts and then to egg. Yeah, and to egg also like needs an extra module. The main module. That's pretty cool. Alternatively, we could just pass that into the yogurt. Would also work. Well, entry, yeah, true. Toast to egg is called entry module. Yeah, let's not do that here maybe. I think it's... I don't know, to be honest. I don't know where that makes sense. I mean, it probably does. Yeah, let's leave it like this. Yeah, and the entry module is the module. Okay, sure. You know what, let's just call this entry module. Also means that there is no confusion with this one. Okay, no main function. But now an egg to yogurt, instead of using some weird module, which doesn't exist, we take the entry module. And within that module, we look for a main function that accepts an integer. Okay, so that works. First, however, doesn't work, which means there are no candidates. That should be an error somewhere earlier in the compiler pipeline. I think in the to egg, yeah. For some call, not a type call, but an actual call, we look for all candidates. Oh wow. Yeah, this is not finished. So we go through all, I don't know, declaration, definition, and wait, how did that, oh yeah, it wasn't a for loop, makes sense. I was wondering how that compiles, but it just said body.parent.inscript, which is a valid expression. Yeah, for each definition in these, for every function, and if def.name, yeah, equals name, and it's a function, then that's a new candidate, like that. Def.name is not a field, it contains module and kind. Well, okay, I don't actually care about the module, to be honest. Just care about the kind. And if that's a function, and then we push def.module and fun.name or something like that. Yeah, so candidates push doesn't work. Let's see. We have a tuple from module and string, and we try to push module and string and source. Seems like it compiles infinitely, which is not correct, you know. Yeah. So what's going on here? maybe let's debug print stuff in the lookup, because that's the function that changed the most. This is where we added the most new functionality, I think. Looking for a call, candidates, and then for every candidate we just print that. Just like that. Does that work? Hopefully. Okay. So looking for a call candidates is, you know, within the workspace test module. Workspace test, yeah, and here we look for a main function. That is great. And then what we do, like this is our candidate. Yeah, okay, so then for some call in the main function we also look for candidates, but there are none, which is unfortunate. Okay, so let's add like a sanity check in here, where we basically say if candidates is empty, then we actually want to return a compiler error. So this will be an error of id error, and we'll actually create a new error. There is no function named name and scope. Yeah, the source of that is the call dot name dot source, I think. Okay, let me guess, tuples can't be printed or something. Oh, name and scope. Yeah, this is supposed to be name dot string. So I expect to see no function named compute in scope. Question is why? Oh, it doesn't do that. Well, this is weird. This is really weird. Okay, you know what, let's print the egg. Why was that not my first intuition? I don't know. In here, we have the bacon, toast, boom, boom, boom. Here we have the egg. I'll probably have to change a few things in order to make this printable. Yeah. Well, that's kind of painful. 131 call dot name dot string. I think that's what it was. Yeah. Okay, so we have the main function. It calls compute. Call compute and then the arguments. And then we'll also put the candidates. And then for every candidate, we print it. And that's a tuple, so this will be, you know, the module, and then maybe colon and the name. Mm-hmm. So we have a main function, and that calls compute, and the candidate for that is the main function. Why? We have a call. We have arguments, sure. We call something that is not a visible variable, so it's not a lambda, which means we look for candidates. Oh, I see, and we go through all the functions that are in scope, which contains the main function. Okay, I see that, yeah. But it also contains the compute function, right? Because that's never mind. Yeah, fair enough. This is not important. I see that. Okay, so there is... Yeah, this is a weird place for that error, I think, because candidates literally contains all functions that are in scope. I see that. Yeah, okay. And then the next part would be when converting the egg to the yogurt. Why don't we see any candidates? That is weird. And let's maybe print compiling, you know, signature. Okay, so looking for a call. And we don't import the compute function. Okay, so there is... Oh yeah, this is like actually looking for the main function. I see that. So then we compile the main function. Makes sense. What the hell? Looking for a call. Candidates is nothing, apparently. Compiling main of main int. Compiling main int. This is weird. Grapes are really great. Why though? It doesn't make much sense, does it? I really don't get it. you know, at this looking for a call, I'll actually, I can't just print the name because I don't know the name here. I see. Let's maybe print the number of candidates. And also in, yeah, exactly, in here. Let's check if okay. So it says 1 candidates, but then it doesn't print any. What? 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 I don't get it. Like, I think something is fundamentally broken here. Hang on. I think when printing the statuses, it actually omits some lines, doesn't it? Oh. Oh yes, it does. Print status, no, just do nothing. Okay, yeah, that is. We're corrupting our own output, that is. Yeah, that's what I want. So looking for a call, there's 1 candidate, the main function. Done printing that 1 candidate. Okay, so then we're compiling the main function. We see there's a call to compute. But there was only 1 function in scope, the main function. Exactly. So what do we do? What do we do? Done printing. Okay, we get the name of the first one. So main. Oh no, that's not correct. Oh, I see. These are all the candidates, not only ones with matching names. Yeah. Okay, let's fix that. Let's say we have the name. Yeah, first we have the egg, then we have the name, then we have the arguments, and then we have the candidates. That makes sense. We can remove this. Yeah, wherever we call that lookup function, we'll have to do stuff a bit different. Yeah, here for the candidates, we'll just print the name, so call dot name, the archetypes, and only then the candidates, which I think is the more natural order to do that in. Okay. Yeah, here as well. We're looking for a function named main of int and the functions that are in scope. Oh no, this is actually not correct. These should be all functions in the entry module egg. Well, who cares? Okay, 865. This doesn't work. Okay, let's guess this is still a source and string. Yeah, exactly. Okay. Here we're compiling main int. Fair. Then looking for a call. We compile it again. Hang on, looking for a call. Let's print the name as well. Because here the name should just be compute. And because there is no function named compute among our candidates, yeah. Looking for a call compute. One candidate, boom. Here are the candidates. Yeah. And then for each of the candidates, oh, yeah. If the candidate B, if that has the correct name, only then we look for the corresponding function in the corresponding module, like for a function with the corresponding module and name. Yeah. Okay. But now it should say no function named compute. Oh, there is no function named compute. Oh, this is amazing. This is honestly amazing. This is exactly what I want to happen here. But once I import that function, now it runs. Okay, that is perfect. Honestly, that is, I can't ask for more. Okay, so I guess we have modules and imports, and if things are not imported, then you can't use them, which makes total sense. Yeah, okay, I like that. Oh, yeah, and you can really see that the main function, when it calls compute, these are the functions, all the functions that are in scope. The main function and the compute function, which has been imported. But the import only says, import a.compute. And because a imports and exports b.compute and so on, like this, gets fully resolved to the actual path that the function is inside of. That's amazing. Yeah, I'm not sure about like circular imports, how that's going to work out. Maybe we'll have to adjust how imports work later on, namespacing and stuff like that. I'm not sure how that scales. Finding the candidates and resolving that is pretty inefficient right now. But at least it works, and it has the right semantics, I think. Okay, yeah, let's remove the debug print thingies and then commit stuff. So this is just debug printing. Yeah, also somewhere I added compiling, yeah, this one. Yeah, that is perfect. These are all the functions in the egg. Amazing. Okay, in scope add something. Where do we say that? In scope add. Yeah, we also don't want that. And that's fine. Amazing. When printing the egg, let's also print the function modules in front of the names, because the egg contains all functions, including like those from inner modules and so on. Everything is merged together. So let's print the module as well to make things unique, to make them unambiguous. Yeah. Yeah, exactly. That's amazing. Okay. Yeah, I don't know what else to say. This is amazing. This is honestly amazing. The built-ins, we could change that maybe. I think you can't call built-ins right now because they are not in scope, which is unfortunate. So let's see how to do that. Let's maybe write a bit. Oh, let's commit that first, and then we can always change more things. Okay, so we refactored the example code. And, well, yeah, this is well to be adjusted to that, but refactor example code, I don't know. Okay, so now let's restructure this code to actually be a bit more useful. There's this part, this is the actual program, the actual test thing. I'll remove that and move that into, I don't know, test B, maybe? B.com instead of A. And in here I should just be able to import, oh, I don't know, dot, but core is not a sibling module. There's another dot required, core, and from core, a lot of stuff, to be honest. let's say maybe type. And some other stuff probably just fails here, but that's fine for now. Okay. Yeah, the standard library should actually be multiple files. So we have one main file, I guess. And then we have, for example, bool could be a separate module. Bool.plum. And in there we would put all this Boolean stuff, like this. That's pretty amazing. Does it depend on anything? Let's see, we define an enum, we switch on that. We call other functions from the same module, and or exo implies, okay, no, bool doesn't depend on anything, which is amazing. Let's also add some more new lines here. Okay, yeah, I see that. That's pretty great. Maybe some sort of format. A bool returning a string, and that could just switch on the bool. If it's true, then we print true. If it's false, then we just print false. Something like that, perhaps. Yeah, hashing, I don't know, like I don't have hashing figured out yet. Okay, so then there are comparisons. Compare.com, comparison.com. I don't know. Ordering. Bool is the type here. The main type. And the main type here is ordering. Let's call it ordering. Yeah. Many types have an inherent order. This module as, you know, functions. That simplify working with such types. Amazing. So we have some sort of ordering, which is less or equal or greater. We have flip ordering, also amazing. We have less than, which, yeah, later on, like these should be operators. Oh, and also, like this only works on ints, which makes sense, I think. Yeah, I'll figure that one out later. Maybe that goes into the int module instead. That would also be fine. Speaking of, we need an int module probably. Oh yeah, there's hashing here, which is not, like I haven't figured that out yet. But still, I'll create some sort of hash file that contains everything related to hashing. And this is just copied from the, you know, Martinez standard library. Yeah. This as well. Bytes don't exist yet, but still byte.plum. And then int useful. And plum. Yeah, you know, I'm gonna write more there and finish, like, you know, in general, write more stuff in the standard library, document things better. That's something I can always do. And I don't currently do that. But okay, so we have that. And then strings. Yeah, not really anything. Maybe it's interesting. That's type that I actually, it's kind of like a higher level data structure, you know, that is not really built into the language. That is fundamental, but implemented in the standard library. That's pretty cool. Similar to result. There are types, which is amazing. There are linked lists. I'm not quite sure about the name, to be honest. For now it's just list, but I think more commonly you would use like a vector kind of list, not a linked list. So maybe I'll name this linked list at some point. Well, okay. What remains? We have some never and crashing stuff. So let's add crashing, I guess. Let's call this never, just because all of these have the names of types, actually. Yeah. And what remains is the nothing or unit or void type. Currently we don't really express that in the yeah, we don't really express that in the function signatures, but that's also because functions can't have side effects. Functions are pure, so functions that return nothing are useless. That's why it's not really a prevalent type, unlike in Martinez. But still, I think there are cases where it may be useful. At least having some explicit version of that here makes sense, I think. Okay. So, what we do here is we import our child module bool, and from that module we import bool. Oh god. This is going to be horrible. And then we export bool. Oh no. Yeah, we import bool and not and equals and or XOR implies and font. yeah, you see for these kind of simple modules where anything is public, where you have where functions are just very, very small. There's a bit of boilerplate here. Tiny bit of boilerplate. Okay. I have to say I like having some sort of, table of contents or like, some sort of overview here. That's actually pretty cool. And yeah, this should be more concise, definitely. Like you should be able to just put all of them on a single line somehow. And yeah, but we'll figure out a syntax for that later on. So we export all the stuff that you need for bools. Very nice. Yeah, bytes, like we don't have anything implemented here. Yeah, hashing, same thing. Integers, well, here we actually do have stuff. We export the plus function minus times slash mod n or XOR shift left shift right power. Oh, look at that. We can export power, but not power recursive. That is cool. So any external module can't even use that. And this is impossible to do in Martinez, for example. Crazy. Okay. Then we have negate. We have the absolute. We have compare. And comparison functions. Okay, let's see. We had pow, we had negate, abs, compare, less, greater, round up to multiple of, round up to power of. We have square root, log 2, and equals. I'm gonna turn this and call this format. Square root, log 2, and equals. And then format. This is amazing. Hang on, ordering had some sort of less than. Yeah, I'm gonna remove that here. Yeah, this should use some sort of format digit helper function maybe. This is still horrible, but not as horrible, I guess. Okay, yeah. And then last digit string. I'm actually gonna put that in here. And here, last digit. Hang on. I'm also going to put that in here. Oh, and you can really see the parallel structure here. And divided by 10 format in the modular 10 format digit. That's amazing. And this would just be digit. Okay, cool. Yeah, parsing ints is another topic. Cool. Very cool, actually. Yeah, I'm just going to clarify linked list. I have several constructors. Checking if a list is 0. Doing stuff with a list. Okay, list of t. Yeah, this should automatically export all functions with that name. That's kind of a limitation, I guess. Only like that you don't have granularity there. But I guess it's fine. Yeah, maybe get map and sum. It's pretty cool. This does depend on ints, though. So I think we also need to import int dot uppercase int, as well as the plus function. Yeah. Oh yeah, in built-in functions, like, those don't work yet. But here, for formatting integers, we also use the plus function. So here we need to import the plus function. Amazing. Right.
Result. Very similar to maybe. Yeah. I guess, yeah.
interesting to import all of that. To be fair, I think this is fine. Like, the standard library should declare everything that it is exporting, so you have, you can easily jump to stuff. You have an overview of what it provides and stuff like that. However, this is very verbose. Later on, when you basically just have a comma-separated list of these function names and operators, I think that's actually fine. Okay, so we have int next list. I'm just gonna put, well, I don't know. Maybe we have another. Nothing. We import all of this stuff. Makes sense. And then we export all of that. Crazy. And the exports don't have that because these functions and types, they are in the current scope. Amazing. Amazing. So this should work. Okay, what do I want to do? Maybe I'll do this list thingy here. test. In the test, I'll maybe name this playground. So import int, maybe and list and map and class and sum. Amazing. I like that. I'm pretty certain this won't compile. Because things such as built-ins don't work yet. Also, I'm not sure about circular imports. But anyways, let's see what happens. Oh, I should maybe make it so that this file is actually compiled. So we want to compile test playground. Probably an infinite loop because of the circular exports. Oh, never mind. Try to import int, but that is not exported. That is actually a nice, error message. Wow. Yeah, the definitions like import and export, they should have want to do some better error attribution. But before I do that, let's this is pretty cool, by the way. The fact that you can just take let's say you have some code that imports some core like some other module. You can just convert that single file into a folder of files and things will work for the most part. That's pretty amazing. Okay, so I don't know, updated standard library, split standard library into modules. I don't know, something like that. Right, what I actually wanted to do is in the toast, the imports, thank you, should have the keyword, I think. Which means that when creating the toast and parsing imports, we'll need to do some extra work. We'll need to, get the keyword And similarly for the export. Yeah, okay, that will produce the same error. But now we can use that keyword when converting the toast to something else. We can now say import .keyword.source. Let's show the error there. That's pretty cool. And if that module doesn't exist, we can also underline the import. So that would be import.keyword.source. Yeah. For the exports, very similar. Just take export.keyword.source. Try and export something that isn't there. Well, you get a nice error message there. Oh, look at that. Amazing. Error in line 2. Oh, hang on. That is not enough information. Errors should not just have, you know, a range and the file content. They should also have a module. They know from which module they are. Error in error.module, comma, line something. Yeah, that means when creating an error, like creating a source, oh, this is amazing. This is honestly amazing. Because in the bacon, yeah, I use the prototype pattern. I create a source prototype, and then I create all other sources by saying, hey, this prototype with range, you create a copy with this range, basically. And now, with the module, I just have to add that up here. Yeah, which means the bacon also needs the module. It needs to know the module. Yeah. Sure. Which means in here and here. Yeah, error.module. Module is not a field on error. It only contains these fields, message and source. Yeah, that is true. That is true. Error in error.source.module. Tried to import int, but that is not exported. Oh, look at this. Error in workspace call list line 2. Damn, that is beautiful. Error in workspace call list line, well, 3, but man, who's counting? Oh yeah, 0 indexed lines, sure. Try to import int, but that is not exported. Oh no. Let's look at that. Indeed, it does not export int. That is true. This feels like, it begins to feel like a real programming language that tells you things you forget. Yeah. Okay, so try to export int, but that is not in scope. The only things in scope, boom. And then there are a bunch of things. Okay, because int is from some built-in module. There is a built-in type. Yeah. I'm not entirely sure how I want to treat built-ins. Definitely not like this. Just having this built-in underscore something function magically in scope. I think instead I'm going to have something like import built-ins dot, and then so I'll have kind of one module that exists, one package or whatever you call this, a lowercase maybe, perhaps. Yeah, but no leading dots. So this is not a relative module. This is more like a global package or something. But this is a built-in package that the compiler provides, that it automatically implements. But that means that for other code in here, for example, we don't just have like automatically built-in map in scope or something, or built-in add-ins or some weird name. You just import int from the standard library, you import plus from the standard library, and that's it. Okay, so import int. Let's see. We do. Yeah, I basically want to import builtins.addInt, import builtins.int subints mul div mod and or xor mul div mod and or xor. Okay. And then I don't need these prefixes anymore. Compare ends also exists. Lower, that doesn't exist, okay. But compare ends. Okay. I like that. All the imports, all the exports. Yeah, the bool really doesn't need anything. That's pretty cool. Yeah, byte doesn't really exist. Yeah, hashing is not a thing, really. So what do we do? Do we need any built-ins here? Probably not. Nope. Neither here. Oh, hang on. Built-in crash. Built-in crash. We can just use the never crash. Oh no. You see, this is horrible. Oh, actually not. We just crash and do nothing else. Yeah, I guess I can just do that. Well, that's simple. Bool. Yeah. Here we use the import keyword, which is perfect. And here we don't. Which is not perfect. In workspace call int, we do import builtins.int. So really in here we want to special case that. If if import is built-ins, then yeah, that works. Otherwise, we just return. Okay. I like that. I really do. So, what's the next step?
The next step would be to return a module. Path is built-ins. A module should also have like a is built-in. And then in here, when I resolve modules, no, hang on, in here, yeah, when getting the content, yeah, I kind of need to skip built-in modules and instead do other stuff. Okay, question is how? Yeah, true. Let's add a constant, like built-in module, and that is a module where the path is just built-ins. Because we have code for checking equality and hashing and so on, checking if something is a built-in is as easy as checking if module equals built-in module. Okay. Yeah, I like that. I like that a lot. Yeah, and in here, oh, hang on, in here, we map built-in module to some sort of toast, I guess. Maybe not. I'm not sure, to be honest. I don't know how that's gonna work. Hang on, at some point we, yeah, imports and exports, yeah, this exactly. We check the definitions that are in scope. That returns def in scope. The defs in scope, and we get the exports of a module, which is also the defs in scope. All right, yeah.
and doing this for today. Well, look at that. Here are the types. Int, string, type, never. These automatically randomly appear here. Instead, these should be specific plum types. And we have a type, and we know which types are in scope. Oh yeah, def in scope should also be maybe I'll just add more things in here. You know. Well, not really, but in here. We have types, we have functions, and then we could also have built-in types and built-in function. I don't know, something like that. And then in here, when checking the, sorry, I have to fix that, built-in type. Yeah, when checking the exports, we basically special case that module. So if the module is built in, then we'll just say, well, this module exports int and something, and we don't actually try to get the toast of the built-in module and so on. Yeah, that makes sense. So here we'll just return. Yeah, this definitely works. Yeah, now instead of special handing that down here, we take these types, type int, type string, type, and type never. And for all of these types, we just export them. And on the type, yeah. So we just do defs dot push that. And we do the same thing for all built-in functions. And there is a file that contains all of these. Yeah. built-ins. Look at that. Hang on, shouldn't that just have the built-ins in here? Probably. And this actually just formats that to a string. Was it to string? I'm not sure. Yeah. Probably here. Yeah, perfect. In playground. Try to import int, but that is not exported. Core.int, and core does not export int. That is indeed true. And I am going to stop for today. It's been a lot of programming, and yeah, there are still things to do here. But they are starting to come together, you know. A basic module system exists, bringing built-ins into scope using the module system seems natural. Yeah, try to import int, but that is not exported. That's errors. Oh yeah, it's imported here, but not exported. Makes sense. No main function. That's different. Well, you know how it goes. You know how it goes. Main. There's a main function. What are you talking about? I don't know. Anyways, I think that's it for today. And yeah, I'll see when I'll get to continue working on this. I didn't record the rest of me implementing the built-ins,
but it's actually not a lot that I did. So I'll quickly walk through that. Yeah, in the toast, we also store the keywords now for better error attribution. I think I recorded that. Yeah, and we just store where the import and export keyword. Oh, I see. Sometimes it underlines the space behind that. That's why. Well, I should fix that. Anyways, yeah, the next stage, the egg, I changed the candidates from a slice to a set. Because if you have some module A, and then modules B and C, which imports some function from A, and then module D, which imports both B and C, and they re-export the function, then if you call that function, there shouldn't be a conflict between this version implemented over this one module versus the other version exported by the other module, because they're actually the same function. They reference the same function. Yeah, so that to fix that error, now this is a set instead of a slice. Which means when converting toast to egg, some things changed. Most importantly, where's that? Where we use a set. Yeah, down here. Yeah, candidates is now a set instead of a list that is then converted to a slice. And also, now the exports can be some different things. So when determining the exports of a module, we usually get the toast of the module, the parsed source code, and we go through the definitions and put them in a map and then export them. Of course, the built-in module doesn't really have a source file because that just exists magically. So what we do here is, if the module is a built-in module, then we return some special casing, a special list of definitions in this built-in module. Maybe I can zoom in a bit more. Maybe not. Okay. Yeah, and the built-in module contains all the built-in types: int, string, type, and never. And it contains built-in functions. Of course, these can't be normal, like toast type defs and toast funs, because again, they expect, this is parsed source code basically. And for the built-in functions, that doesn't exist. It's my neighbor. So I added some variants, instead of just having a type and a fun as possible definitions, we also have a built-in type and a built-in fun. And the built-in type just directly stores the plum type. And the built-in fun stores the built-in, which was this big enum of all built-in functions. Right. Yeah, that's just attributing the imports. This as well. Yeah, this built-in module is now special cased. That also means that down here in when lowering types, we don't have to special case these built-in types. You can't just write int in your code and expect to get an int, but we have to import the int type from the built-in module in order to then use int. Of course, you can just write a 3 in your code, and that has the built-in type int, but to actually name that type is not like a keyword or something. You have to, like any other type, you have to import that. So basically, this right here moved up here. These built-in types and built-in functions, they no longer exist automatically. One other thing, apart from debug prints apparently, is that the built-ins are now created once per compilation, not once per toast. So rather than in each file the built-in functions are automatically in scope, rather than that we put them into scope one time in here. And yeah, basically this is like compiling the built-in module and the functions for that. Oh yeah, a nasty error was that this right here, converting, iterating over all modules and compiling each of them. This didn't handle errors because this returned a result, and that wasn't handled. So now there's a question mark after that, which means if this fails,
if any of the module compilation fails, then this entire compilation fails. This was this was difficult to find. Yeah. Okay. I think that's all of these changes. What's down here? Oh yeah, when looking for types and functions, we have to also handle the built-in types and functions. So for example, if we look for a type with a given name, then we can't just go through all the definitions and check, is this a type? Then we check if the name matches, but we also, we have to check, is this a type and does the name match? This is just renaming def to type. But we also have to check, is this a built-in type? Then that may also match. Yeah, and for funds and built-in funds, nothing happens. All right, yeah, this is just some general code cleanup. This uses a set instead of a list, the usual things you expect. Okay, yeah, that's actually it. So egg2, the egg now has a set of candidates, which means that this was just, a set when compiling the egg to the yogurt, when figuring out which overloaded functions we use, we also pass around these candidate sets instead of slices. This is just improved error messaging. And the one thing that really bothered me after this was that there was some bugs in here where, because this is an enum with not just a type and a function, but also built-in type and built-in function as separate, separate enum cases, that meant that down here this code looked like it was correct, but actually it wasn't. So this code where we check, is this, we look for some type with a given name, rather than, yeah, this code looks correct on the surface. We look for a type with a name, so we go through all definitions, and if the definition is a type, then we do something. Similarly, down here, we look for a function. So what do? We go through the functions, we see is this a function, then we add that to our candidates. But actually, because built-in type and built-in function are also enum variants, they also need to be handled. So this needs to be changed from, is this a function, to this thingy here. Is this a function? Then we need to put that. Then we need to put that into the candidates. Is this a built-in type? Then we need to put that into the candidates. And up here as well, is this a type? Then we check if things match. Is this a built-in type? Then we check if that matches. And in the other cases of fun and built-in fun, we do nothing. And similarly here, in the case of type or built-in type, we do nothing. We just continue. And this is, initially I forgot to update these. I forgot to update this check and this check, which meant that when you call a function, you import, I can even show the code for that. In int, for example, we import builtins.addInts. Here, when you call that function, add ints, that wouldn't actually get resolved. And I was like, why? Add ints is imported. It's not in scope. It's not in the list of candidates. And figuring out that there were these different enum variants for type and built-in type and fun and built-in fun, that wasn't intuitive. So then I also refactored that from one enum into 3 enums. Basically a nested enum. I kind of reverted this to the original way it was designed, that it's either a type or a function. And then each of these is another enum. That is either is a built-in type or a custom type, or a built-in function or a custom function. Which means, this gets a bit more complicated, getting the name from something, because, again, nested enums. But these types, these things right here, they got a bit simpler. Removing debug prints, that's also nice. So this right here could just be, if this is a type, like it was before, like this code, then we switch on the type and handle the built-in and the custom type as separate cases. And this, functions, we don't even have to handle that. And similarly here, rather than checking is this a fun or a built-in fun, then we add something to the candidates. Otherwise, we don't do anything. We just do one check, is this a fun? And then we put something in the candidates, and what we put in there depends on whether that's a built-in fun or a custom fun. So this kind of cleaned up the code. And with that, built-ins now work. And I had to adjust some of the core library features because like imports were not, there were some imports missing. Yeah, you can see that the built-in types are now imported as well. We have, we import like the basic functionality for ints. Some of these don't even, here for example, no, hang on here, rather than defining a crash function, which then calls the built-in crash function, we just import the built-in crash function and then export that crash function, which makes sense. Yeah, so that's really cool. Some of these functions just got removed entirely because you don't need them. Yeah, similarly here, instead of defining a type of function that calls the built-in type of function and a type info function which calls the built-in type info function, we now just import the built-in functions and then call them and then re-export them directly, just because they have the correct name already. Yeah, I'm not entirely sure about this, to be honest, because with these built-in functions we can't attach any form of documentation. We can't, if you go to jump to definition of type of, we can't do anything about this. Here you have this readable type signature. It takes a T, it returns a type, and you can jump to definitions of these. So, from an ergonomics perspective, having some place in the actual source code where these are defined probably makes sense. But for now, I think it's fine like this. Yeah. At some point, if I have like renaming of imports, like import builtins.typeof as built-in type of maybe, then I can define my own wrapper function down here and just export that. But we'll see how that pans out. Okay, so that's essentially what I wanted to achieve with modules and imports. One thing that's kind of bothering me is that the code is a bit verbose. Because you can only always import one function, one type. So I want some sort of better syntax for importing, and it's actually nice that I postponed the syntax stuff until now, because now I have a clear semantic understanding of what imports mean and how those could look. So how could imports be a bit more concise? Imports and exports as well. So Plum is an annotation-based language. So I think it makes sense for this to be, let me move me down there again. Yeah, so I think it makes sense to kind of display imports as a tree, maybe. And also, we don't have nested modules. Like this is some module, and this module can only export types and functions, not other modules or something like that. So you can't actually export some sort of structured functions and definitions in a structured way. You just import them all in the same namespace, which I think is fine for now, to be honest. Which means I'll kind of embrace that, and maybe let me just write something down. So Plum is annotation based, which makes it natural, I think, to put to have one import and export statement, and then these indented things are the ones that are exported and imported. Like you can do multiple ones, you know, but this is basically equivalent to having multiple imports here. Also these dots, you don't really need them because, you know, dots imply some sort of member access, but for modules there is no nesting. We could just replace these with spaces, I think. Boom. And then the question is, what about, you know, this int module that imports two things? Maybe we can even put them on the same line. And similarly here. Oh. Yeah, I don't know. Oh, look at that. And it even goes in a single line. I'm comparing that to what it was before. Much more concise. Yeah, and I like this, by the way. Having this, you know, I import this and this and this. These are the modules, and then here are the imported definitions, both types and functions. And each line consists of a string for the module, and then the names of the definitions. If you import really like a lot of things, we may even allow, yeah, let's, you know, these import int thingies here. I'm just gonna remove these. Yeah, kind of like this. Yeah, this is, I want to allow line breaks here. But just doing it like this is weird, because it should be indented. And this is also weird, because now you have these, you know, these imports that are right. Oh, maybe that's actually fine. No, I think I'm going to either have them on the same line or on a separate line, similar to how function calls work. Compare, less and greater, and then you have these. Yeah, this looks clean. Let's maybe refactor this just to see how that pans out. So we import bool, we import several Boolean functions which fit on the same line. Oh yes, this is concise. You import bool, and then the stuff you import from bool, and int, and the stuff you import from int. Then some list stuff. Yeah, this is clean. Nice. I really like that. Yeah, that maybe the unwrap. We have crash. We have nothing, and apparently several functions for nothing. We have an ordering, including flipping and ordering. Yeah, including results and unwrap. Oops. And types. Nice. Yeah, this is pretty cool. You know, for the standard library, which really imports and exports a lot of things. I think this is reasonably concise. So exports, yeah, pretty similar. Just put them on the same line, break them when they are too long. Well, yeah, cool. Very cool. Later on, we may even, you know, automatically format these, like sort them alphabetically or something. I don't know. Yeah. But for now, this is super fine. I think it makes sense to have imports and exports right next to each other as a convention at the beginning of the file. Yeah, that's cool. Nice. Let's implement that. So currently this doesn't pass. I hope it doesn't pass. Yeah, no, this is fine. Okay, so it says import. Oh, I see. Yeah, this is parsing stuff I noticed before. Yeah, we look for import with a space afterwards. Of course, that's not the correct way to do that. Not at all. Okay, let's see, we have some bacon and we have okay, I think for imports there are basically either it's a single line import, something like this, or it's an import with potentially multiple lines below. Yeah, so this is just going to be, if the line is just import and nothing else, then this is multi-line import. Yeah, otherwise it's a single line import. So what we do here is we pass import, and we say, oh, this is no match. Yeah, if it's a single line import, let's consume white space afterwards. Oh, I see, this is consume. Is there like a consume keyword or something? Nope. Okay, but I can, I can do parser.end.consume this, or if there is no space afterwards, then it's also no match, because I don't want to match a line that says this. This should not be passed as an import. Okay, so there has to be the keyword, then at least a space afterwards, then we pass a string, and I hope that parse string also consume. Yeah, consumes white space as well. So yeah, that's kind of, yeah, that does mean that this won't work, because before parsing the space it consumes white space. What we need to do instead is check that the current character has white space. Okay, then we pass the string. Perfect. A dot. No, let's instead do nothing here. Like this, yeah. And then pass identified. Yeah, that also consumes white space. So, oops. No need for this right here. Oh, yeah. Question is, how do we model imports in the toast? Should have done that first. Does it make sense to kind of expand an import into multiple ones? I think not, because in the long term I want this toast to be basically a representation of the original source code. including comments and pipes and calls and stuff like that. So this will be a single import. And we'll have to handle that later in the egg. Okay. Okay, so we have an import. It has a keyword. And then it has module imports, maybe. You know, with module string and then definition. Imports, something like that. The imported definitions, you know. And this right here is parts, I don't know. A slice of module import singular. Well, these are multiple. Let's call them toast import part. I don't know. Yeah, something like this. And similarly, the export will be a slice of definitions. Amazing. So toast import, for a single line import, you can't actually import stuff from multiple modules. It's always just a single module. But you can import multiple definitions. So we create a list here. Yeah, and then we basically need to loop and parse identifiers as long as we can. Yeah, if there's no other, then we just break and we push that to the list of identifiers. And then two things are bad. If the parser is not at the end, is at end. Oh yeah, ensure it's at end. Amazing. That's nice. And then the definitions also can't be empty. So if definitions is empty, then bad. Amazing. Ensure is at end. What does that do? Oh yeah, return the result. Amazing. So we can just do this. This does not work because we're pushing a list. Oh, string and source is that. That is true. Yeah, we may want to underline the, if something can't be imported, then we may want to underline the specific identifier instead of just the import keyword. But that's improvement later on. Like this is, you know, these finer details. That's totally fine. We don't care about those. Okay, the parts field is missing, but not in here, but in here. Parts is just a single part. So this of a toast import part with the module and the definitions. Amazing. Okay. What's going on here? That doesn't make any sense. I don't get it. But fine. My neighbor going at it again. Okay. Yeah, multi-line import. Let's deal with that. how does that work? Either, yeah, kind of like this, right? Yeah. Yeah, if it's a single line import, then we consume input and a white space. Now we know this is actually an import. So we ensure that we don't have any children. A single line, or like, you know, this is an import that has something else on the same line, but it also has children. Multi-line import should just have a line with that says import. I don't know, this is weird. This is not, well, that's fine. Okay, so for the multi-line import, it has children, and each of these children is going to be passed into a part. Yeah, that's going to be another function, plus import part of some bacon, result maybe I don't know, toast, import part, and error. Nice. And yeah, we call that up here. Yeah, I'm gonna continue working on this later.
Okay. Let's maybe go back to see how imports look like. So this is a single line input with one input part, which has a module and definition or name that is imported. And these have multiple parts. So we need to parse each of these children as a part. Yeah, in the end we want something like this, perhaps. You know, return a parsed import with our key word, which is just the line, I guess. You know, bacon.line. Add bacon.source. I think that's how you create a string in source. And the parts are our parts converted to a slice. Yeah. And for every child in our children, we basically want to add that to a list of parts. Okay, yeah, this looks fine. And the import part is, yeah, going to be returned down there. So this will be, you know, bacon parse import part, and that can fail probably. Yeah, that seems right. Yeah, bacon line is import, then all our children have to be parts. Amazing. Okay, parse import part.
and this needs to return a part. Can it also not match? Probably. I don't know. I don't know. Oh, I don't know what happens with comments, for example. But that's something, you know, for figuring out later. So parsing an import part. That is basically the second part of this. We parse the module, which is just a string. And that has to be on the bacon line, so I kind of need to create a parser for that line, like this. We parse a module. If that doesn't work, then, yeah, let's say this returns a maybe. Why not? And if that doesn't work, then we're just saying, you know, we expected a module here. Yeah, hang on, sorry. Okay, yeah, expected a module here, and then this import part has definitions which are similar to the ones up here. Although, again, there are two versions this can work. Either these are on the same line, or they are on different lines. So, if parser is at end, then, you know, next, like our children contain the names. Else, the rest of this line contains the names. I think definitions is actually a weird name for that. Because your bool, sure, that's a definition. Format is a definition, but really these you know, one of these can refer to multiple underlying definitions. For example, you can have a module that imports multiple plus functions, and using import plus, you import all of them. So this is not a single definition, this is more like a name. I think I'm gonna rename this to name. Names, plural. That's the at least a more general general term for that. Alright, yeah, this is probably gonna fail somewhere, but that's fine. This doesn't work because this is supposed to return a toast import part. Okay, our children contain the names exactly. So for each, well, we have the names as a list. In this case, where we don't have any children, we shouldn't have any children. So let's say bacon.children is empty, or return bad input. So what's the matter here? We have stuff for multi-line. What's the imports? The imported names should be on separate lines from the modules, something like that. Oh, this is a horrible description for that, but no. Yeah.
So then we loop parsing identifiers or breaking and push those to the names. Perfect. Then in here, if we are at the end, then we still want to build names basically. And this is also correct. But we also want to make sure that, well, we basically want to walk through the children, and for each child we want to pass the names. So for each child in Bacon children, we want to build a parser, and on that parser, oh yeah, here we should do parser dot ensure is at end. Yeah. Same here, and in between we push. We do this looping. So each of our children, we're just going to pass the identifiers there, space separated. And yeah, that's it. That is nice. So now we have names. The default case evaluates to a result, nothing error, but previous cases to nothing. Okay, so this returns, oh, this returns a result. That makes sense. Did I? No, here I do. Here I, bubble that up. That is correct. Okay, sure. So inconsistent return types. Expected result. Actual is other result. No, that is fixed actually. Let's just run this and see what the actual error is. Okay, so this call doesn't work. This is the signature push. Oh, this is still a maybe. Right. 640. Here we need to also make sure that there is an import out there. Otherwise we return bad input of an error. Expected module. I don't know, something like that. With the Bacon source. Now let's put that on a new line. Beautiful. Okay, import and type def. Bacon to toast 6555. These have to be empty, otherwise we return toast import true. Six, 7, 2 down here. Ah yeah, we need names. These are called names. Sure. Then the names field is missing for the exports as well. That makes sense. That's down here. Let's call these. Oh yeah, we want to allow multiple here. So I don't need that. I'm going to copy that from up here. Names is this. Boom. So we build a list of names, pass identifiers to ensure that there is nothing coming afterwards. And if there weren't any names, then this is bad, because we exported names is what we expect. Okay, yeah, and I think this can, let's say this is the, yeah, okay, yeah, that's fine. Okay, and these are just the names converted to slice. Beautiful. And yeah, toast export
import is what we want there. Module is not a field on toast import. That is true. Yeah. So in here, for every import, I see. Yeah, we also need to handle the parts. So for every part in import parts, we do this. Pretty much this, just this. Which means we resolve the part module, or if there's an error, we return, oh, there's an error, blah, blah, blah. Wonderful. Module is not a field on toast import part. Yeah, this should work. Okay. Not a field on toast import, hang on. Toast to egg, yeah, okay. And the next compiler stage. That I can do. 16 is in here. Imported module is this. Yeah, same thing basically. You need to go through the parts in the import, so yeah, we resolve the part module, we say, oh, there's an error otherwise, then matched something equals false, sure. Yeah, so basically for each name in part.names, we want to import that name. So matched something is, we look for a definition with that name, otherwise try to import name, but that is not imported, not exported. Beautiful. Yeah. Same for exports. This is where, yeah, resolving the exports. Where we look at the exports, sure, and then for every name in export names, we basically do this. Yeah, this is the name, then things are fine, otherwise they are not. Oh damn, this compiles. Well, let me take a short break answering some people. Okay, yeah, I don't know why this is, the error is displayed in a super weird way here. Yeah, I don't know. So let's maybe why is that so weird? Like additional garbage online in test playground, especially because hang on, in the playground. Oh, that is actually true. Well, I did not consider that. Yeah, these are invalid. They have a space there, which is a bit cleaner. Oh, but still super. It should display the error, you know. Workspace core line 2. Workspace core line 2 import. Line 2 import
really don't get it. What is that trying to tell us? And this was in line 0. Weird. Very weird. Okay. I'm gonna remove that. Does it now say line 1 or something? Oh, what's going on? Expected module, line 2. I don't know what's happening there. Expected module. Expected module and multi-line. Oh. Expected import parts. Oh no, actually. Yeah. Yeah, okay. The same thing still exists 2 times for some reason. Expected module, import part, and the import. Okay. Expected module. Well, I don't know what that is. An import part, and this one a single line import. I don't know what's going on. Why is the line an import part? Okay. So we are down here. Parse import part is called, no, with the child. Well. Oh, look at that. That is pretty cool. So apparently this got parsed. That's nice. And then this one didn't get parsed. Additional garbage on the line. So this is a multi-line import. We're parsing import parts, which happens down here, where we expect the module. Then we say ensure is at end. We say we parse that thing. Parsing the module. Maybe this should be, consume white space afterwards, but I don't know. Yeah. And then for each child, we create a parser that just parses identifiers. Yeah, makes sense. Okay, so this is probably the case for the first line. For this bool import, they get, there are no children, and we just pass the identifiers, that's it. In here though,
we go through our, same thing, passing the original bacon to the parser instead of the child. Okay. I mean, that's pretty amazing. So export is not working because it probably doesn't have, oh yeah, this is horrible, and it doesn't have multi-line handling. So let's add that. If, you know, something similar to this. Yeah, parser is something. And yeah, let's have that at the beginning here. And the keyword, let's adjust that to something like this. So that, you know, with export, of course. Just to make sure that errors can be displayed at the export keyword directly. Yeah, and here we check if the entire line is just export. We do this. So for each child, oh yeah, now we're basically trying to do this right here. Our children contain the names. So the names are an empty list of strings, and then for every child we create a parser of that child, not the original bacon. We repeatedly pass identifiers on that parser, add them to this list, ensure that there is nothing coming afterwards, and then in here we just say, okay, we've passed an export of these names. Beautiful. Yeah, some of these imports still have dots. So now let's just adjust all the imports from core and style library and so on. Yeah, these are all, let's condense them, you know. The field int list maybe string type variant plus list net sum. Boom, everything on a single line. Beautiful. In here we import a compute and foo. I'm not saying it's readable and it's nice, but it's at least, you know, as far as imports go, this is pretty free of boilerplate. That's nice. Yeah, once you accept that, you really want to import everything and like everything explicitly. I think this is the way to do that. Nice, really nice. Bytes don't really exist. Hashing doesn't really exist. Oh damn. Yeah, I mean, built-ins int, add to compare stuff. Oh, look at that. This becomes a multi-line thing. This one doesn't. This neither does this. Or this, although it has multiple inputs. There's really, I like that is these new imports are grouped into import built-ins and then all the built-in stuff, bool and all the bool stuff. And doing this by indentation feels very natural, like a natural fit compared to, you know, like functions in Plum. Okay, here we try export things. Well, several things. And yeah, this is a lot of stuff that we export. So what? We have 2 lines of exports here. I think that's fine. This is already updated. Very nice. This one isn't. So let's do that. pool import string but nothing format equals ignore, like this. Amazing. Import string, export result, and unwrap. Import built-ins string, export string, and plus. Here we import several things. And we also export several things. Sure. Yeah, like that. I think that's basically it. Updated imports. That is pretty great. Let's commit that. Only a lot has happened. Yeah, okay, but most of that was just updating updating the imports and exports to be more concise. I mean, yeah. I think that's pretty cool. Import list, maybe, never, nothing, and then the things you import. Clean, simple, indentation based like the rest of the language. I like that. Really, really nice. Yeah, okay, so these all get smaller, that's for certain. Yeah, the toast has keywords here, yeah, and has parts with modules and names, makes sense. So they have to be parsed differently, also makes sense. Parser is getting, well, not super long. I mean, 1,000 lines is still fine, I guess. But, yeah. This is amazing. Yeah, and finally toast to egg has to be, yeah, handles all the parts when determining the definitions that are in scope. We handle the imports differently, and when determining the things that are exported, the exports, we handle exports differently. That makes sense. Okay, yeah, make syntax, make, I don't know, imports and exports more concise. Amazing. Yeah, I think that's it for today. Stuff is coming together, I have to say. Like, the fact that you can split code into multiple files, you know, that you have these files that can import and export stuff, that everything is not in a single namespace, you know. Things begin to look like a real programming language. That's pretty nice. Right, so I guess see you around. And yeah.